everybody, very warm welcome to Vedantu JEE English channel. This is me, your master teacher Nabamita Ma'am, and today we are here to complete the longest two chapters. These are GOC and hydrocarbon. Also, I'm not very sure if we'll be able to complete hydrocarbon because GOC itself is a very long chapter. So the moment I feel that, topics are bouncing above your head, we will stop it right then and there, and we will have a part 2 of it, okay? Alright, so how are you all doing, everybody? How are you all doing? How is your preparation for your computer science exam? How did the bio exam go? I think it was super duper easy, everyone. Good evening. Good afternoon. After 4 o'clock, it's evening, bacha. It's good afternoon. Yes. So, now that we'll be completing these two chapters, what will happen from these two chapters? From general organic chemistry and hydrocarbon, if we complete it, there are chances that we will be able to complete a lot of questions. These are the fundamentals, these are the basic. Even the class 12th organic chemistry is somewhat based on that. So it is very necessary that we clear our concepts here so that we can attempt most of our questions from organic chemistry in our JEE paper. Yes, so how are you all doing? Are you all excited to see if organic chemistry also becomes easy peasy biryani tasty? I had my lunch today. Yesterday I had my lunch, everybody. Because I kind of knew that today's session is going to be very long and I did not want to take chances that I will, faint and fall off. Did not want to do that. Hence, I did have my lunch. Alright, so quickly go and call up your friends, everybody, as well, so that we can start. To those students who are already here, why does this not work? Just a second, Just a second. Quickly go call up your friends, everyone. Had a lot of biryani. No, I did not have biryani. Yeah. Just a second, yeah. Please quickly call up your friends. I'll be back in a minute. This remote is not working. Please check the remote. Okay. Yes, hi Shri, ma'am can need. Yes, absolutely. Dora, I cannot confirm how much will the lecture last, but definitely 3 hours at least. Yes, lifestyle. Yes, bacha, you can watch it. NEET aspirants can also watch it. As we know that the chemistry for JEE and NEET is almost same. So yes, you can watch it. Alright, to those students who are already here right on time, thank you so much for coming right on time. And all the new students who are here for the first time, please don't forget to like, share and subscribe. I see that many students are watching but you're not liking. Please smash the like button. No, thank you so much. It really does help me. Like I said, Vedantu will also get to know that yes, Nabamita Ma'am is a good teacher. Otherwise, they will think that, she's not a great teacher. Not a good teacher. So do that. Hi Kalpana. Hello everybody. Yes. So shall we start, everybody? Without much further ado, let's start. Also, quickly go and call up your friends, everyone. Yes. Chalo. Let's begin. Yes. La. That's the way to show excitement. Chalo. So we will be starting from the very basic. Yes, we will be starting from the very basic so that every single thing that we need to understand about general organic chemistry gets absolutely clinical clear. Okay. Now, the first thing that we understand is organic compounds. NCERT enough for organic? Not at all. No. Simple answer, no. Anyway, organic compounds can be divided into two categories. Okay, two broad categories. Now, one is acyclic or open chain compounds. Yes, open chain compounds, right? And the other one is cyclic or closed chain. What do we mean by cyclic? It's like a circle, right? It's like a circle where everything is closed. As you can see, everything is closed, right? Now, in acyclic compounds or the open chain compounds that we are talking about, here also you have two different kinds, right? Here also you have saturated carbon. Yes, you have saturated compounds which only have single bonds. Yes, which only have single bonds, right? For example, you have ethane, that is C2H6. C2H6. Yes, it's a single bond carbon compound, right? And that's a type of acyclic or open chain compound. Now, moving on to unsaturated or double or triple bond. Now, this is the basic that you have actually learnt it in your 9th and standard as well. Yes, when we got introduced to organic compounds, carbon and its compound, if you remember that chapter. Yeah. So, unsaturated, which is double or triple bond. Yes, you have ethene or you have ethyne. Yes, these have double bond or triple bond. So these becomes your acyclic or open chain carbon compounds. Okay. Now when we go to cyclic or closed chain compounds. Okay. Just a second, guys. Let me check if this is working. Yes, it's working. Amazing. Tarun, I will not skip, bacha. Yes, I need you all. I need that when a student is coming here for the first time, I need them to understand from the basic every single thing so that you know each and everything. So I'm not going to skip everything. I'm going to teach you all of it. Okay. Now what happens to cyclic or closed chain carbon compounds? They can be carbocyclic compounds which has only a carbon ring. And there can also be heterocyclic compounds where there is a ring which also contains, okay, which also contains carbon and other element, okay, other element bole to oxygen. Yes, example is pyridine, furan. Yes, these are the examples. Now when we talk about carbocyclic compounds, my dear student, the carbocyclic compounds can again be alicyclic compounds, for example cyclobutene, or they can be aromatic compounds, and the most popular aromatic compound which everybody knows is benzene, okay, which everybody knows is benzene, okay, benzene, very good. All right, moving on from here, now we are going to talk a little bit about functional groups. What are functional groups, my dear student? Functional groups are basically those groups, okay, an atom or a group of atom, okay. Basically what they do is they determine the properties of the organic compound, particularly the chemical properties. What do? They determine the chemical property in which they are present in. Yes, in which they are present in, right? For example, if you see, this is a hydrocarbon. As we have learnt from the chapter hydrocarbon, there is carbon and there is hydrogen, so hydrocarbon. Now in this case, if I deduct one hydrogen and if I add one OH group, instead of the hydrogen, if I add OH group, what will I get? This OH is the functional group, my dear student. And because this whole thing is derived from this hydrocarbon, we will call this as a derivative of hydrocarbon because it is derived from this, right? Almost similar structure, just that instead of having one hydrogen here, we have an OH, which this OH we will call it as functional group. And yes, as you all know, this is basically nothing but an alcohol functional group. Yes, making sense, everybody? Till here it's absolutely easy peasy biryani tasting. Now, we also learned something about homologous series. What is homologous series? What is series? What is a series? A series basically is, my dear student, as we all know, a series is what? A series, you know, arithmetic progression, geometrical progression, these are all series, isn't it? 1, 2, 3, 4, 5, 2, 4, 6, 8, these are all series. Yeah? Same way, organic compound, okay, organic compounds, they have similar properties, they are kept in same series, okay, and such a series where they are differentiated only because of a particular number, we call it as a homologous series. As you can see, your alkane series is here, see, C2H6, C3H8, C4H10, that means it is only differentiated because of CH2. CH2 is the difference between these two. CH2 is the difference between these two, as you can see, right? Now, when we go to alkene series, you see C2H4, C3H6, C4H8, these are the examples. Alcohol series, CH3OH, C2H5OH, C3H7OH. So, you see that every next one, yes, every adjacent molecule in the series, they are differentiated by a particular group, right? Same way you also have aldehyde series, isn't it? Yes. All right. Moving on from here, now let's understand. Now let's go to a little bit, you know, little away from the basic, and we're going to understand the nomenclature of organic compounds. Yes. So till here, everybody, you guys are understanding? Till here, everything is all clear, guys? Yes. Till here, everything is all clear? Amazing. Now we are going to understand the nomenclature of organic compounds. So how do you name? And why do we name? We name it because, hey, there are millions of organic compounds and it is near to impossible to understand each and everything. Yes, or to remember each and everyone's name. So rather, what we can do is we can always have a rule. We can always have a rule to how we can name a compound. For example, we have IUPAC. IUPAC can be basically considered to be the parent of chemistry, and they name everyone. They always name everyone. So let's see how we can name them. Okay. So first, what you do is you have to write a prefix. Okay. And basically, most of the time, the prefix is actually a functional group. You write the halogen like chloro, bromo, etc. Then comes a root word. Now, root word is the nature of the carbon chain. Okay. It's the nature of the carbon chain, right? Yes. Moving on, you also have to give it a suffix. And the suffix can be a primary suffix which will basically talk about the double bond or the single bond or the triple bond. Like if it is alkane, then ane. If it is alkene, then ene. If it is alkyne, then yne. Okay, this is what you add. But apart from this primary suffix, you will also be adding, you might as well have to use a secondary suffix, which will be basically your functional group. If it is alcohol, then ol. If it is aldehyde, then L. If it is a ketone, then ONE. If it is a carboxylic acid, then you will have to say it is oic acid. OIC. Oic acid. Yes. Is this much clear, guys? Clinical clear? Can I get to see some la 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 or EPBT? That is easy peasy, biryani is tasty. Till now everything is clear? Yes. Now here is a cheat code for you. I'm going to tell you a cheat code also in some time, okay? Yes. Don't keep telling me that I have a doubt. I will not spend so much time. The chapter as it is very big. You have a doubt? Ask the question, okay? Don't try to deviate my focus from teaching you. You have a question? Spam that. I will answer. Yes? Don't utilize so much time. I have a doubt. Then I will ask you, beta, what is your doubt? Then you will tell me that, ma'am, this is my doubt. Then again, I will have to answer. Why spend so much time? Just tell me what's your doubt. Ask the question directly. I'll answer. Okay, if I can. Acha. Now your cheat code is, my dear students, see, secondary prefix plus primary prefix plus word root plus primary suffix and then secondary suffix. Okay. This is what is your cheat code. Now, just let me give you an example. Imagine that this is what it is given in your exam. Okay. CH3, CH, CH, double bond, CH, CH3. Okay. Now, what's your carbon chain? The parent carbon chain, this is your word root. This word root, this is your word root. Yes, your parent carbon chain, this is your word root. Got it? Now, what you're writing, see, you have a single bond here, you have a double bond here, yes. At third position, you have a double bond. So, this will become your primary suffix, right? Yes. Now, here you have a substituent prefix. See, you have a substituent here. Something is substituted here. CH3 is right here. It is substituted, okay? All right. Now, here you have a secondary suffix. You have a functional group as well. Okay? All right. So, what will be the name? The name will be 5-methyl hex 3N2-ol. At the third position, you have a double bond, so N. At the second position, you have a alcohol group, so ol. And you have at the fifth position, you have a methyl group, so 5-methyl. There are 6 carbons, so that's your word root, that is hex, then 3N2-ol. Understood? Yes? Yes? Okay? Triple bond with total 8 carbon change, and what is there? Fahal, I have just told you how to name it. Just told you all the rules of nomenclature, bacha. Please try to get it on your own. Okay? Yes. So this is our example. Now imagine that you have all single bond. All single bond you have, and this is your chain. Okay? So here what do we see? I see that 1, 2, 3, 4. There are 4 carbon. Yes, 4 carbon. And I see that here you have COOH, which is your carboxylic acid. This is your carboxylic acid, right, my dear student? Yes, absolutely yes. At the second position, you have a halogen, that is chlorine, and at the third position, you have methyl. So what will it become? 2-chloro. Yes, that's my secondary prefix. 3-methyl, primary prefix. Yes, primary prefix. Then I write my word root. The word root is butane, and then oic acid. That's my suffix. Is this clear, guys? Easy peasy biryani is tasty till now. Yes, nomenclature is absolutely easy. So if there is any question in the exam, will you all be able to do it? You will be able to do it. Okay. Now, the names of the straight chain hydrocarbon, it consists of word root and primary suffix. Okay. Word root and primary suffix. For example, if there is carbon 1, just one carbon, it is word root will be meth. Yes. If it is 2 carbon, then eth, 3 carbon prop, 4 carbon but, 5 carbon pent, 6 carbon hex. Okay. And like that it goes on and on. Okay. Like that it goes on and on. 7 carbon heft, 8 oct, 9 non, 10 dec, 11 undec, and 12 is dodec. Okay. This is how it goes on. Alright, now moving on from here, guys, what are the rules for naming the compound? Let's understand the rules. Till now we have understood the, basic of nomenclature, right? The basic of nomenclature is all clear, right? Yes? Yes, everybody? Absolutely. Now we also have to understand the rules. If you remember, yes, he got fired. Yes, Fahel, shh, focus up. Long big chapter, yeah. Long big chapter. Don't deviate, huh? You'll not be able to focus up. Yeah. Now there are rules for naming the compound. See, just like that, you can't come and tell that this is the name that I want to give to the compound. You can't do that. Huh? It's not your whim that works in chemistry. There has to be a rule, right? There has to be a rule. Otherwise, all of these rules would have been a joke, है ना? है कि नहीं? तो joke नहीं बन सकता. ठीक है? तो First rule everyone, the first rule is, okay, you select the longest continuous chain of carbon. Now it doesn't matter if it is straight or not, we don't care about it, okay. It can be like this, it can be zigzag, it can go down, it can go this, it can go there, whatever it can do. The only thing that we want is it has to be continuous, not discrete. It's not light, it's organic. So what do we need? We need it to be straight. No, we need it to be continuous. We don't need it to be straight. We need it to be continuous. It has to be continue. Okay. Now in between, if there is a Cl or you see something else, don't consider. Okay. So example, let's take a look at the example. See, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. This is our longest chain. Here also, this is branched. This is not straight. I could have considered this also had there been another carbon or another 2 carbon. But because there are only 8 carbon, which one is longest, my dear student? 8 is longest, 9 is longest. 8 is longest, 9 is longest, 9 is longest. What will I consider? I will consider the 9 carbon, okay? Wherever I see more carbon is present, my chain has to be long. That's all is my concern. I need it to be long, okay? Yeah? Okay. Also make sure that it contains the functional group, okay? Yes, also make sure that it has the functional groups also in it. Now moving on from here, once you have selected the longest carbon chain, now you have selected the longest carbon chain, now you start numbering the carbon atom, okay? Yes, now you start numbering the carbon atom. Now when you number the carbon atom, what should be your concern? Your concern has to be such that, yes, writing the name of the compound of the substituent, which is alphabetically first, should be written irrespective of its locant. Doesn't matter where you can, okay? First you can explain fastly. What am I doing, Abhi Gaming? I didn't understand whatever you're saying. Anyway, so see, example, you have 9 carbon here, yes. At 6th position, you have a branch here. At 2nd position, you have a methyl group here. Isn't it? Yes. Okay. Yes. So what will I do? I will follow alphabetical order. E comes first or M comes first? E comes first. Right? So what will I do is, I will write at 6th position, it is ethyl. At second position, it is methyl, and then there are 9 carbons, so nonane. There are no double bond, it is alkane, so nonane. Yes, that's it. Yes. Now, if by chance there are, let's say that at second position, if there was something else also written, okay, at second position there was something else also written, then what will I do? What I will do is, if there are 2 numbers, then I will separate them with a comma. I will separate them with a comma. Yes, yes, all right. And if there is a number and there is a letter, see, there is 6, 6 is a number, E is a letter. How will I separate that? I will separate that with a hyphen. Hyphen, you understand, no? A dash, basically, that's it. Yes, I will separate that with a dash. All right. Yes, everybody. And the first letter will be capital letter. After that, see, there are no capital letters, guys. No capital letters. You must follow it. You must follow it. Do not make a mistake. See, in the exam, there might be questions like this which can confuse you. Yeah, there might be questions like this which can confuse you. So just make sure that you know these rules. Okay, moving on from here. Now, if there are 2 different substituents, let's say there is a methyl and there is an ethyl, okay, at equivalent position. At equivalent position. The numbering should be done in such a way that alphabetically preferred substituent should receive the lowest number. Didn't understand, huh? See, example. See, in the previous one, 1, 2, 3, 4, 5, 6, 7, 8, 9. Like this I have taken, right? But now I see that if I give this 1, 2, 3, then ethyl which is alphabetically also coming fast. Yes, ethyl is coming first alphabetically also. If I give this position to ethyl, third position to ethyl, then it makes more sense. It makes more sense. Then ethyl will get the third position. So 3 ethyl and 7 methyl, that makes more sense. That makes more sense. So I can write it as 3 ethyl, 7 methyl, nonane. That will be easier for me. That will be easier for me. Okay? Alright? Yes? Got it? Clear? Okay. Sure. Moving on from here. Rule number 4, everybody. Your rule number 4 is, when a molecule contains 2 or more identical substituents, okay, use numerical preference such as di, tri, tetra. Now, what will I do? Prasad, can I please teach you first? You might be knowing all the concept, but what if there are new students who do not know and they are trying to figure it out everything from the basics? So, please let me teach everyone. Yeah? Yes. In this world, we shouldn't be selfish, huh? We shouldn't be selfish. Let's do it. Let's think about it for everyone. And even you, if you are sitting here, you will also be revising. No? So, chill, Mari. Everything will be completed. What does Nabamita Ma'am say? NB Ma'am always says, easy peasy biryani is tasty and clinical clear. So, when you step out of the class, it will be clinical clear, my dear student. I know, sorry, yeah, chill. It's okay, no sorry. You are all my students. I don't mind everything. That's why I explain, hai na? Okay. Huh. Yes. So, now, think about it this way, okay? Now, will I write 3 methyl? Seems weird, no? Why will I write it? Say, even in English, don't we say, Ram went to eat food, Ram took a bath, Ram went to school, Ram played in the playground. Will we keep writing Ram? No, we use pronouns. Ram ate his food, he went and he caught the school bus, he went to the school and he played in the playground. Yeah? We don't use the same thing again and again. This is the very same way, my dear student. Understand this, that instead of using 3 methyl, instead of that, what we will do is 3 dimethyl. Makes more sense. And life also becomes easy, right? Instead of writing METHYL, why write so many letters? When we can just write 3, DI. That's it. Right? No, you don't have to underline, bacha. That it's not biology, it's chemistry. Yeah? It's chemistry. So, no underlining. Okay? Okay. So, 2, 3, 4 substituents respectively. However, their initial alphabet should not be considered for ordering the substituents in the final naming. So, see. Here what we are doing is 7 ethyl. Again, once again, E is a previous alphabet, right? E comes first. Then what am I writing is, I'm writing 3 dimethyl. Okay. Now see, D comes before E, but will I consider D? Will I consider D? No, I will still be considering M. M is my letter that I want, okay? M is the letter that I want. So I will write ethyl, 7-ethyl, 3,3-dimethyl nonane. Am I right? Am I right? Yes? Got it? Got it? Clear? Alright. Okay. Moving on from here, now naming of a compound with a compound that contains one or more functional group. So here are some rules. It's written here. Let me just read it so that you all can just MBE. You did not understand. What is it that you did not understand, bacha? If you did not understand, what you can do is just rewind it a little bit and watch it again so that you can understand it clear. What is it that's not clear, MBE? What happened, bro? Huh? What happened? Bulu bulu? No, ma'am. Now I don't see any other response. Chalo, anyway, let's move on. Okay. So basically, what are the if there are one or more functional group, then what do we do? Let's see. A longest continuous chain of carbon atom is to be selected in such a way that it includes as many functional group. Okay. As many functional group, and the numbering of carbon atoms is to be done in such a way that the functional group receive lowest possible number. Is this clear, guys? What are we saying is there is a long carbon chain. My consideration of the carbon chain must be in such a way that I find the longest continuous chain of carbon atom. Okay. And I have to make sure that in that long chain, there are also the most amount of functional group that I am covering. And while I am covering the most amount of functional group, I have to name it in such a way that the functional group get the lowest possible number, not the highest. Yes? Made sense now? Made sense? Is this clear, bacha? Okay. Coming to the second point. In case of polyfunctional compound, one of the functional group is chosen as a principal functional group based on the priority. Yes, we will come to that also. There will be a priority list, okay? Priority list, yeah? Priority order, which is to be treated as a suffix, and rest all are to be treated as a prefix. Acha, you tell me. A lot of you come and ask, no, ma'am, should we focus on board, or ma'am, should we focus on JEE, ma'am? JEE, bro, JEE. It's JEE that is going to help you. Board is just for your qualification, not even qualification. It's just the fact that you have to pass it. That's it. JEE is the one that is going to help you to have your dream job later, to have your dream life later. JEE is just eligibility. I mean, sorry, what do you call it? It's just eligibility. Your boards are just eligibility. Bro, stop, stop trying to butter me up. Not gonna help. Yeah? Stop trying to butter me up. It's not gonna help. Yeah? You focus on what I'm teaching you. Not on my face, not anywhere else. Yeah? Focus on what I'm teaching you. Not really. Actually, what matters more is your JEE marks. Yeah? Unless you are not appearing for JEE and you have a completely different route that you want to choose for you, like me. I did not sit for JEE, right? I'm not an engineer, but what did I do? I completed my bachelor's in science, I completed my master's in science, I completed my research fellowship, and then I landed here. So yeah, then maybe your board marks might matter, but it really doesn't. Eligibility is enough. That's it, okay? That's enough. Okay? Yes. Exactly. And if you study for JEE, then board is going to be just a cakewalk. Just a cakewalk. Hello everyone. Hello guys. Hello. Welcome. Okay. Now moving on. So if the organic compound that contains a functional group, multiple bond, a side chain or substituent, the following order of prefix must be followed. What is the order? The order is functional groups, double bond, then triple bond, and then side chain. Okay. Functional group is given the priority. Then you give the priority to double bond. Then you give it to triple bond, and then finally to side chain. All right. Yes. Yes, Raj Kiran, it is. Okay. Middle class lifestyle. Do you want me to do that right now, or can I teach now? Later I will check it out. Yeah. Later I will check it out. Yes. Chalo. Acha, moving on. Now let's understand some of the prefix and the suffix name of various functional group. Now what if, okay, what if we have a functional group? We must know their prefix and the suffix. Hey guys, focus up here. So many questions if you ask me. I will not be able to answer. Do you think that I'm Durga Mata or am I Ravan? I don't have 10 heads, yeah? Neither do I have 10 hands. I can't answer, I can't, do so many things together. So let me teach now. We'll answer all of that at the end of the session, okay? So you stick till the end of the session. At the end of the session, we will talk to each other. We will answer some of the doubts, whatever questions you have. All right, then we will do that, okay? Ha. Yes, listen now. Chalo. So let's say that you have an acid halide. The prefix would be halocarbonyl and the suffix will be carbonyl halide. Very easy, no? Very easy, isn't it? Yes. This one, bacha, double bond is prioritized, then triple bond. Here, I just told you. Okay? Ha. Acha, moving on. See, prefix will be halocarbonyl, suffix will be carbonyl halide. Okay? Alright? Yes. Now, if I have alcohol, yes, which is the OH, yes, OH. For prefix, I will write hydroxy. For suffix, ol, right? Like pentanol, butanol, propanol. You have seen that, isn't it? Now, if I have an aldehyde, what will I do? I will write formyl as a prefix, or I can also write oxo, yes. But if I have to have a suffix, I will write it as carbaldehyde or Al, yes, okay. Now, amides, prefix will be carbamoyl, suffix will be carboxamide or amide. Amine, A-M-I-N-E, amine. If it is an amine, then it will be amino, and if it is the suffix, then it will be amine. Suffix will be same as it is, amine, okay. Then we come to carboxylic acid. If it is carboxylic acid, prefix will be carboxy and suffix will be carboxylic acid, okay. Yes. Moving on. Ethers, again all of this chart is given to you, so let's not spend so much time on the chart because you will be getting the PDF from which you can study, okay, from which you can study. We will do some of the questions also, don't worry, practice questions are coming up, chill mari guitar guy Harsh. You will get everything, don't worry. PYQs, practice question, your DPP, everything is here. Cheat sheet, tips and tricks, the whole concept of the chapter, all of it. You eat popcorn, write down if you can certain things and just chill, okay? And just chill. Chalo. Now, the order of priority of various functional groups. Now, if there are a lot of functional groups, then of course priority is needed, no? Priority is needed. Like I just told you that if you have a lot of exams, like right now you have AP board coming up, TS board coming up, this CBSE board coming up, JEE exam coming up, then in some time you will also have EM set. Which one do you have to prioritize? JEE, always JEE. You study for JEE, you will be able to clear all of them. The very same way, the order of priority of various functional group is also necessary. So what do we have? We have COOH, carboxylic acid, then SO3H, then you have COOR, then you have COCl, then you have CONH2, CN, CHO, okay, C double bond O ketone, then you have OH, then you have SH, then you have NH2, then you have double bond, and then finally triple bond. Triple bond, priority of triple bond is at the end. Priority of triple bond is at the end. All right, okay? Sure. Now, my dear students, my dear champions, yes. Now, please tell me this answer. I am going to ask you, assign the IUPAC name to the following compound. You tell me. What is it? Is it option A, 5-methyl hex 2-YNE? Is it 2-methyl hex 4-YNE? Or is it 5-methyl hex 3-ine? Or is it 2-methyl hex 3-ine? Tell me. Let's see, guys. Let's see, everybody. Come on, come on. Let's check it out. 1, 2, 3, 4, 5, 6. Okay. Then what will it be? 1, 2, 3, 4, 5, 6. Don't you think that it is option A? Option A, right? Yes? Yes, it is option A. Very good. Very good. Yes. So 5-methyl. 5-methyl. 1, 2, 3, 4, 5, 6. So 5-methyl Hicks 2-YNE. Here at second position you have triple bond. So YNE. Very good. Well done. Moving on. Now let's understand a little bit of benzene. Okay. Let's understand a little bit of benzene. So nomenclature of substituted benzene compounds, right? Mono-substituted benzene compounds. What is mono-substituted benzene compound? That means one substitution will be there. Yes? Yes, Dora, I will be taking another lecture at 7:30 now. Shh. Why will it be pen, bacha? There are this. Acha. This is why I asked this question. Don't you think that here also there is one carbon? So 1, 2, 3, 4, 5 and then 6, na? And then 6. So you forgot that. You forgot that. Huh? You forgot that. See, this joint is also a carbon, na? This is also a carbon. So it will be hex. Okay, it will be hex. Okay? Yes. Ma'am, ignore कर रहे हो basic चीज. कौन सा basic चीज भाई? मार खाओगे punch, virtual punch. Should I need you? Should I give you? This is the basic, the most basic question that I can ask you. What are you telling me, Sadav? Go. You know what? I challenge you. I double dare you. Go to YouTube, search for GOC one shot and see if this is also there in the session. Check it out. फिर come back and tell me. In one shot, see if this is there or not. Then come back and tell me. It's a lot of struggle that, you know, I'm taking care of everything, okay? Yes, I'm taking care of everything. नहीं बच्चा, YouTube है. आपके doubts मैं यहाँ पे पढ़ा के लूँगी, ठीक है? आपके doubt मैं यहाँ पे पढ़ा के लूँगी. तो shh and listen. आप इस तरह से नहीं कर सकते, ठीक है? ये personal coaching थोड़े ना है. I'm teaching you on YouTube. So here, you will get your doubts cleared here, ठीक है? Anyway, so mono-substituted benzene basically is, there is one substitution, yes? There is one substitution. So, naming the substituted benzene compound, the prefix used for the substituent is prefix to the word benzene simply. Basically, C. CH3. So, methyl benzene. That's the IUPAC name, okay? Here you have OME, that means methoxybenzene. Just before benzene, add the substituent. That's it. Okay. That's it. NH2, aminobenzene. Understanding, guys? NH2, aminobenzene. NO2, if it is there, then nitrobenzene. If it is only bromo, bromo is what? It's a halogen. Yes. So what do you write? Bromobenzene. That's it. Easy peasy biryani tasty. Very easy, isn't it? Great. Now, there is also possible that in a benzene ring, you might have different positions where the functional group are present. Yes, you might have different positions where the functional group are present, like ortho, meta, para positions in mono-substituted benzene. Okay, so when do you use this ortho, meta, para? Yes, you use it only for di-substituted benzene. When in the benzene ring, there are two positions where they are two positions the substituents are holding, not for mono-substituted. For di-substitution, you use ortho, para, meta. Now, when is it ortho? When is it para? If it is C, if it is like this, opposite, right on the head opposite, then you write it as para. Then you write it as para, okay? But if it is, see, one head and then leaving one position here, then it is meta. Meta was meta. If it is just adjacent, then you write ortho. Am I clear? Then you write ortho. Got it? Got it, everybody? Is this clear? So ortho, meta, para. Okay. So 1,2-dibromobenzene will be your orthobromobenzene. Okay. Ortho-dibromobenzene. If it is 1 and 3-dibromobenzene, then it is meta-dibromobenzene. If it is 1 and then see 1, 2, 3, 4. This will be 4. Okay. 1,4-dibromobenzene, then it will be your para-dibromobenzene. Cool hai? Clinical clear, guys? Yes. Now tell me one question. What will be the correct IUPAC name for the following compound? Is it 1,3-dinitrobenzoic acid? Is it 1,5-dinitrobenzoic acid? Is it 1,5-dinitrobenz-3-oic acid? Or is it 3,5-dinitrobenzoic acid? Come on, guys. Can I have the answer here? Can I have the answer, guys? Go ahead, let me know. What do you think is the answer? Quick, quick, quick. You have to answer faster. Do we have the answer? Ha! Now I see a lot of answer. Very good. Okay. So many students are saying option D. Let's check it out. Yes, absolutely right. The correct answer is 3,5-dinitrobenzoic acid. Okay. 3,5-dinitrobenzoic acid. Absolutely correct. Well done. Now let's understand isomerism. Okay. So from here, the main section of it actually starts. Okay. From here, the main section of it actually starts. How? Explain. See. 1, 2, 3, 4, 5. Right here, you are already giving it the priority, isn't it? You've already given it the priority, so don't mention it once again. It's fine. Yes, you have already given this the priority. COOH. This is your carboxylic acid. Carboxylic acid suffix is what? Oic acid. Oic acid is the suffix. And from here, 1, 2, 3. 3 at third position you have a nitro. At third position you have a nitro, and then 4, 5 at fifth position you have another nitro. So there are 2 nitro. That means that at third position and at fifth position dinitro, 2 nitro, benzene, yes, benzene ring, and then carboxylic acid. So dinitrobenzoic acid. Clear? Yes, clear? That's it. That's it. We'll do more questions and things will get easily explainable. Don't worry about it. You will understand. Just chill. Just chill. Everything will happen. There are more than 100 slides here. I swear to God, you will be able to practice. You will be getting your daily practice paper. Your concepts will be getting clear. Just chill, Mari. It's okay. It's just the beginning. Just the beginning. Now coming to isomerism. Now my dear students, if you remember, isomerism is something that we have also learnt in coordination compound. Is that right? And coordination compound, if you remember, I had explained it very well. Right? Yes. Coordination compound I have taken so many times and I have explained it so many times. Now in coordination compound also we have learnt about structural isomerism and stereoisomerism and all of that, if you remember. Henna? Yes. So what is structural isomerism? Structural isomerism, as we know, when the compounds have the same molecular formula, my dear student. Same molecular formula, yes, but different physical and chemical properties. Why? Why? Just because of different connectivity. That means different constitution of atoms, then they are said to be structural isomerism. Yes, just different connectivity, that's it. That's it. And then when we come to stereoisomerisms, they have same molecular formula. Yes, just the different arrangement in this space. Okay, see. Same molecular formula. I'm going to just highlight it, everybody, if you can see. Highlight it here. Okay? Same molecular formula, but different arrangement of atoms in space. Okay? Different arrangement of atoms in space. This is called as your Stereoisomerism, right? This is your stereoisomerism. But in case of structural isomerism, what is it that we have spoken about? In structural isomerism, I have said that the compounds have same molecular formula, but different physical and chemical properties due to why? Different connectivity. Okay, different connectivity. That's it. Got it clear? Yes. Now there are different types of isomerism. Obviously, chemistry, so mysterious, right? There are a lot of mysteries here. Structural isomerism is, as you see, there is chain isomerism, there is position isomerism, there is functional isomerism, there is metamerism, and there is tautomerism. Okay, and there is tautomerism. So let's understand each of them one by one. Ready? Then let's understand each of them one by one. Apart from that, when we come to stereoisomerism, we have geometrical isomerism, conformational isomerism, and optical isomerism. Pretty similar to coordination compounds. So I hope that we will be able to run and fast. Tautomerism, there are certain kinds, but it won't be too tough. Chill. Okay. So first of all, chain isomerism. What is chain isomerism? Now, chain isomerism arises due to difference in the arrangement of the carbon atoms constituting the chain. Venkata, I'll make a video about it and I'll tell you, okay? Right now, focus here. I'll tell you. I'll make a different video and I'll make you, okay? I'll do that. Yes. Very nice, bacha. What a nice way to grab ma'am's attention, right? Blame teacher that you don't know anything. That's why you're not responding. I'm not responding to you because what you are asking is a repetition. Watch it again. Don't do this. Don't do this. Yeah. No, don't. I'm not going to provide you attention like this. Yes, you are not God that I have to take your name 108 times. And like I said, it's a very big chapter. So please make sure that you are here. You're focusing up. Don't do this again and again. I've already given you this thing, given you attention twice. And you are trying to just deviate me from the concept. Don't do that. Thank you. Chain isomerism. Why does a chain isomerism arise, guys? Why is it that chain isomerism arises? That's because the difference in the arrangement of the carbon atoms. Yes? The carbon atoms that make up a chain, if there is a difference in the arrangement, then it gives rise to chain isomerism. For example, you have butane. This is your butane, 4 carbon. 4 carbon are there in butane. Absolutely right. Now, if you see 2 methyl propane, this also has 1, 2, 3, 4, 4 carbon only, no? 4 carbon only. But the carbons are arranged in a different way. See, here it's completely in a chain, but here you have a branch here. You have a branch here. So at the second position, now you have a methyl and you have changed the name to propane 3C. Clear hai? Yes, clear hai? Both of them have 4 carbon, but it's just the arrangement that is different. Do you notice? It's just the arrangement that is different. Okay? Moving on from here, now let's understand the unsaturation number. So the molecular formula of an organic compound, it contains information, my dear student, okay? It contains information about the number of rings, if there are any rings. If there are multiple bonds, then that will tell you. Obviously, you write it, no? Alkane, ene, wine. It does give you, isn't it? Now, the presence of rings or the double bond within a molecule is indicated how? By a quantity called unsaturation number. There is a quantity that tells you about it, which is the unsaturation number of a hydrocarbon. How do we find it out? Unsaturation hydrocarbon is denoted as capital U, and capital U can be given to you as C+1 minus H minus N divided by 2. Now, what is CHN? What is CHN? Let's understand. C is the total number of tetravalent atoms. Total number of tetravalent atoms. Yes. H is the total number of monovalent atoms. Yes. Monovalent atoms. N is the total number of trivalent atoms. If there are any atom that is trivalent, then you write that also. Is this clear, guys? Is this clear? This you might want to remember it, okay? This you might want to remember it, okay? Now moving on from here, position isomerism. Chain isomerism is over. Now let's understand position isomerism. What is position isomerism? See, there are a lot of compounds that have the same molecular formula but different in position substitution. Yes, they have different in the position substituents or functional group. Or the functional group is also, functional group is at the different position. That's it. So for example, if I take the example of C4H8, C4H8, see, 3 plus 2, 5, 6, 7, 8, 8 hydrogen and 4 carbon, absolutely yes. Here also see, 3 plus 1, 4, 5 and 6, 7, 8, 3, 4, 5, 6, 7, yes, 7 hydrogen. I think this should have been CH3, yes. This should have been CH3, so 8 hydrogen, 4 carbon, right? But now check it out, here the double bond exists here. At the first position, the double bond exists, right? But here if you see, it exists in the second position. So but 1 in and but 2 in, both of them are position isomerism. Both of them are position isomerism. Do we understand this? Do we understand this? What did I say? Compounds having the same molecular formula. Molecular formula for both of them is absolutely the same, isn't it? Molecular formula for both of them is absolutely the same. But different in position substituent. It can be a double bond or a triple bond. It can be a functional group as well, okay? It can be a double bond or a triple bond, and it can be functional group as well. So this explains our position isomerism. This explains our position isomerism. Okay? Another example let me give you. See, C3H8, oh, H should be here, or no, 2, 2, 4, 5, 6, 7, 8. So no. Where is it? C3H8O. Now what I can do is, at the first position, I can put ol, right? At the first position, see, propan 1 ol, I can do that. Or what I can do is, I can shift it to the second position. Yes. So it will become propan 2 ol, right? Propan 2 ol. Do you see? Do you understand here how this is happening? How this is happening? Do you understand this? Exactly. That's what we mean. Okay, that's what we mean. Now here I explained you with a double bond. Here I explained you with a double bond. And here I also told you about a functional group. Our functional group being, what was our functional group? Our functional group was this, OH. Alcohol was our functional group. Okay, alcohol was our functional group. Venkata, are you catching a flight, bacha, in 5 minutes? Do you have a flight in 5 minutes? Yes or no? No, no? Then give me time. Give me time. As I move forward, I'll explain. No, right? Then wait up. You can see I'm explaining one by one, no? Can I jump? Huh? Can I jump? When you went to the movie, when you watched RRR, what did you go and tell? That, hey, NDR, bring me the Natu Natu song, no? Why are you taking so much time? Would you do this? No. Now imagine this is also a movie hall. In the movie hall, you can't ask me to skip the part and jump. Okay? I can't skip the part and jump. I have to explain everything, no? Yeah. So I'll go there, chill. I'll go there and I'll tell you. Don't worry. Just be here. Chalo, moving on. Now it is observed, due to the presence of different functional groups in a molecule, there might be a rise of another isomerism, right? There might be another isomerism, which is called as functional isomer. So what did we learn? Chain isomerism, position isomerism, and the third one is functional isomerism. See, I am covering it. Third isomerism now. Third isomerism is functional isomerism. See, here I can have an alcohol. Yes. CH3, CH2, alcohol. This has an alcohol, right? Now with the same formula, C2H6O, I can also have an ether here. ROR. I can also have an ether here. RORCH3OCH3, this is an ether, this is an alcohol. Yes, but the molecular formula, my dear student, check it out, is the same. The molecular formula is the same, but these two are different. Yes, the functional group is different. This gives rise to a functional isomerism. Clear hai? Crystal clear, clinical clear, everybody? Easy peasy, biryani is tasty. So chain isomerism we have understood, position isomerism we have understood, where we spoke about a double bond or a triple bond can be there, or a functional group can be there. And here we have understood about functional isomerism. So easy peasy, biryani is tasty till now. Same formula but different functional group. Absolutely right. Yes. So easy peasy, biryani is tasty, right? Awesome. That gives me happiness. Now, let's talk a little bit about the homologous series and the family of compounds. See, if you have the formula of CnH2n plus 2, okay, then consider this to be from the family of alkane. Yep. Okay. CnH2n, what will it be? Alkene or cycloalkane? Okay. Yes. Okay. If it is CnH2n minus 2, what will it be? Alkyne or cycloalkane? Diene. Diene is also possible. Diene is also possible here. Okay. If it is CnH2n plus 2 dot O, O is also there. Now what it can be? It can be an alcohol, it can be an ether. We just saw, see, ether. Yep. If it is CnH2nO, then what will it be? It can be an aldehyde, it can be a ketone, unsaturated alcohol and cyclic ether. This is our possibility, okay? This is our possibility. Yes? Okay. Now, CnH2nO2. CnH2nO2 is carboxylic acid, ester, hydroxyaldehyde or ketones. This is our possibility. Hai na? This is our possibility. Understood? Okay. Now moving on, there are some more type of functional isomerism. Okay. There are some more type of functional isomerism. As you can see here, nitroalkane. Do you see nitroalkane and alkane nitrite? Same, bacha. Same. Absolutely same, isn't it? Do you see? CH3, CH2, N, double bond O, and here also. So NO2. CH3, CH2, NO2. I can write NO2 as ONO, or I can write it as NO2 like this. Do you remember from coordination compound? NO2 was an ambidentate ligand. Do you remember? Pretty much the same way. It can be nitroalkane or alkane nitrite. Making sense, guys? Making sense? Everyone? Yes. Alright. Now, understand this. Alkane nitrite, CH3C, triple bond N. Yes? Alkane nitrite. Alright? Or what can happen is alkane isonitrite. Only thing that happened was instead of CN, I wrote it as NC. Remember? Thiocyanate and isothiocyanate. Yes? Remember that? Exactly, my dear student. Yes? So that's all. These are the different type of functional isomerism. Okay? Alright. Now some more type. It can be alkane cyanide, if you see, alkane cyanide, or it can be alkane isocyanide. Now this, my dear student, is called as methyl isocyanide. If you remember, the Bhopal gas tragedy happened because of this gas. Now this is a general knowledge. If you know, you know. Great. If you do not know, it's fine. I mean, nobody will ask you in the question that because of which gas, the Bhopal gas tragedy happened. But this is what it is, okay? Bhopal gas tragedy happened because of methyl isocyanide. Alright? Methyl isocyanide. Got it? So that's what happened. Chalo. Moving on from here, let's understand metamerism. What is metamerism, guys? Okay? What is metamerism? Let's understand that. Just a second. So, metamerism, when does metamerism arise? So, till now, what are the things we have understood? Chain isomerism, positional isomerism, functional isomerism, and now we understand metamerism. In case of metamerism, what happens is, the compounds have the same molecular formula but different structural formula. Molecular formula is absolutely same. But the structural formula is different. Yes, is different because of what? Yes, see. Formula due to different nature of alkyl groups present on either side of the polyvalent functional group called metamers, and the phenomenon, as in the incident, this whole program, this is known as metamerism. Okay, it's known as metamerism. Now the polyvalent functional group, okay, polyvalent functional group which shows metamerisms are your O, S, NH, N and CO, etc. Okay, these will show you metamerism. Example, obviously, without example, how can we understand something? We will not be able to understand anything, right, without example. So here comes your example. Check it out. Molecular formula is C4H10O. Yes, C4H10O, that's our molecular formula. Now this molecular formula can form a diethyl ether, ROR, C2H5O, C2H5, right? Or it can form methyl propyl ether. I can make it C3H7O and CH3, so methyl propyl ether. Make sense? Make sense? Right. Now, talking about another, next example, C5H10O. C5H10O can form diethyl ketone. C double bond O is here. No, this is C double bond O, ketone. So, diethyl ketone can be formed. Or I can also make it as methyl propyl ketone. Yeah. Third example for you, my dear student, check it out, C4H11N. So I can make it diethylamine. It can be a diethylamine or it can be methyl propylamine. See, CH3, C3H7. So methyl propylamine. Yes. And this is ethyl. This is also ethyl. So diethylamine. Making sense, everybody? Is this making sense, guys? Is this making sense? I hope this is making sense to you all. Yep. All right. Chalo. Now from here, moving on, let's understand tautomerism. So some of you are saying that, ma'am, tautomerism is very hard. Yes, tautomerism is very hard. So let's understand that in tautomerism, there are actually different kinds. But let's skip it. Let's only understand one. Okay, that is keto-enol tautomerism. So in case of keto-enol tautomerism, what do you see? What do you see? That this is a ketone group, C double bond O. This is a keto. Yes. And this is what? This is an enol. This is an enol, right? This is an enol. Okay. So keto and enol, this is becoming your keto-enol tautomerism. Yes, this is becoming your keto-enol tautomerism. All right, everybody. This is clear? Making sense? Not making sense? Not making sense because you are spamming so much. I stopped watching the chat, but let's see if there are any doubts here now. Yes, absolutely right. Absolutely right. Okay. So, we have understood this also. Makes sense, no? Clear. Amazing. Now, moving on from here, let's understand geometrical isomerism. So, we are basically done with our, pretty much we are done with our structural isomerism. Now, we come to geometrical isomerism. Pretty same way as we have learnt in the coordination compound, geometrical isomerism here also comes as a cis or a trans. What is cis? Cis, you can see that CH3, CH3 on the same side CH3, CH3, same side HH. But when it becomes on the opposite side, see H is here, H is here. CH3 is here, CH3 is here. So this is called as trans and this is called as cis. Okay. Similar substituents are on the same side of the double bond, then we call it as a cis isomer. And if the similar substituents are in the opposite side, like if this is here, if this is here and this is here, then it will be called as trans. If both of them are here, then it is cis. If this is here like this, then it is a transposition. Got it? Yes? Alright. So the different arrangement of atoms, okay, in a space. How they are arranged in the space. These guys have the same formula, they have the same molecules, everything is same. Just the way they are arranged in the space, okay, just the way they are arranged in the space, that gives them a isomeric form. That makes them a geometrical isomerism. All right? Yes. Now, the different arrangement of atoms in a space remains fixed. Why? Why? Due to the double bond cannot rotate, if you remember, yes. Restricted rotation of double bond makes them like this, okay? Makes them like this. Understood? Yes. Now, what are conformers? What are conformers? Do I have more pens here? Let's try to understand this with pens. Acha. What are conformers? Okay? So, different momentary arrangement of molecules obtained as a result of free rotation of single bond, not double bond, single bond are called conformations. Okay, let's check it out, guys. Let's check it out here. Okay. So, imagine I have something like this. Okay, I have something like this, right? Now, just behind this, if I make another one like this, I wish I had more hands now. Okay, I wish I had more hands now. But just beyond this, if I keep, can you see the second structure that I have in my hand? Can you see the second structure in my hand? No, right? But actually I do have, see, the second structure. Can you see it? Can you see it? So this will be called as a totally eclipsed. Let's understand them. Okay, let's understand them one by one. I hope you have seen the structure that I just tried to tell you. Okay, so dihedral angle. See, there is a dihedral angle here. Okay, now understand this. This you might not understand, but check it out here. See, so when you're trying to look at it from here, right? When you're trying to look at it from here, it is possible that just behind this is completely hidden. Isn't it possible? Isn't it possible? It is, right? It is. Now let's understand one by one that what can it be. So when I showed you, when I tried to show you this, you saw that the second one, the one that was near to me, that one that was behind the camera, you couldn't see it. Why? Because it was totally eclipsed. It was exactly behind the front molecule, so you couldn't see. So that's called as totally eclipsed. Now it is also possible that you are able to see all of them. You are able to see all of them, okay? From the side you can see all of them. That's called as gauche. That's your gauche form, okay? But imagine that just behind the CH3, it's not, see, here it is CH3, right? Behind CH3, there is a CH3 that is hiding. But if behind CH3, there is an H atom that is hiding, that will be called as eclipsed. That's called as eclipsed. Not totally eclipsed. Eclipsed, just eclipsed. What am I telling you is basically, if this is my front carbon, if this is my front CH3, and if behind this I have a hydrogen, now you can see it somehow, right? You can somehow see it, isn't it? Somehow you can understand that there is a hydrogen atom and not CH3. So this is my eclipsed form. This is my eclipsed form. But if I have, let's say, CH3 and I have a CH3. Now can you see the second pen? Now can you see the second pen? You can't. So this becomes totally eclipsed. But there are two pens. There are two pens here. See, this becomes your totally eclipsed. Got it? Clear? Okay. So we have understood this also. Okay. This is your conformers of N-butane. Okay. These are your conformers of N-butane. But there is a possibility of this forming an anti also. See, CH3 just exactly opposite to like this. Okay. If this is my CH3, just exactly opposite to this like this. Okay. Just exactly opposite to this. Like if it is absolutely ulta of it. Like for example, if I draw a triangle like this and if I draw a triangle like this, then what is it? This is exactly opposite of this. So this is anti. This becomes anti. Okay. All right. I don't know, Baba, that was an example. Luxury Hitler, I was just telling you an example. That's why this is also eclipsed. This is also eclipsed. We just for our convenience to make people understand, we call it eclipsed. Honestly, even the H atom is hiding behind CH3. But we call this to be eclipsed and we call this to be totally eclipsed. Okay. Alright. Just so that we can explain it for our convenience, okay? For our conveniently, we want to explain it to everyone. So that's why one is called as totally eclipsed, this is called as eclipsed, alright? But otherwise, yes, the H atom is completely hiding behind the CH3 because CH3 is a bigger molecule, right? The H atom is completely hiding behind. So yes, that's absolutely right. Chalo. Then again you have, you know, eclipsed, gauche and totally eclipsed, alright? So conformers, I hope that you are understanding. Is conformers getting clear? Alright. Now what happens is all of them have different energies. Why? If it is a CH3, then there is another CH3. These are both big molecules. Both of these big molecules, when they are here, there will be repulsion. They will try to repel each other. They will try to repel each other. Yes? Yes. Isn't it? They will try to repel each other. So what will happen? The energy will be higher. And which is exactly what is written. See, totally eclipsed has a higher energy. Totally eclipsed has a higher energy. Then comes gauche. Gauche has very little energy. Eclipsed once again has a little higher energy. Anti has very little energy. Yes, then again eclipsed has higher energy. Then again gauche has little less energy. And then totally eclipsed will have again, once again, higher energy. Totally eclipsed because both the big groups are in the same position. So when are they going to be stable? When it is ulta like this. When it is anti like this, at that point of time, they will be more stable. But like this, they will start repelling each other. Yes, they will start repelling each other. So is this clinical clear, my dear student? Are we clear till conformers? Is everything clear? Is everything clear till conformers, everybody? Yes? Oh no? Yes or no? EPBT, easy peasy biryani is tasty. We can say that. We can say that. Can I have some more EPBT on the chat box if everybody understood? Blessy is dabbing. Awesome. Oh, thank you, Speed. Thank you so much. Alright, moving on. Now, let's understand what? Optical isomerism. Acha. So, there are various terms that are used in case of, you know, and minimum of anti. Yes, ma'am, understood. Easy peasy biryani tasty. Thanks, Harsh. Okay. Now, when we talk about optical isomerism, my dear student, of course, there are certain terms that are used in optical isomerism. We cannot deny it, right? How much ever we say, we cannot deny it. Sanjay, don't say that, yeah. Biryani is very tasty. My favorite food. Don't say that. I don't know where you had biryani, but biryani is tasty. Anyway, so, what are the things that we talk about? We talk about symmetry. We talk about chirality, achirality. We talk about chiral carbon, and we talk about plane polarized right. Now out of this, some of them are absolutely dictionary meaning, but anyway, let's understand this. What is plane of symmetry, axis of symmetry and center of symmetry? Okay, plane of symmetry, axis of symmetry and center of symmetry. Now this here, please focus up. There have been some questions in the past that have come from here and it's slightly confusing guys, just slightly confusing. So if you focus up, you'll be able to crack it. If you don't focus, I wish you all the best. Huh? Chalo. Understand. Plane of symmetry you understand, right? Basically, what do you have? You have an imaginary plane which passes through the what? Which passes through the plane so as to act like a mirror and it divides the molecule into two equal halves. So basically this was what you had. Now you introduced an imaginary plane. You introduced an imaginary plane. When you introduced an imaginary plane, you also imagined that this cut the molecule into two equal halves. Yes, this cut the molecule into two equal halves. Yes, you understood? Understood? Yes. Okay. Now, from here, plane of symmetry, let's understand. So, plane of symmetry can be introduced like this. It can also be introduced like this. It can also be introduced like this, right? And it can be diagonal as well, okay? And it can be diagonal as well, right? Yes. Now, when we talk about axis of symmetry, see, please focus up here. Axis of symmetry is an imaginary line. We spoke about plane of symmetry. Now we are talking about axis of symmetry, okay? What is axis of symmetry? Basically, what we are talking about is we are introducing an imaginary line. We are introducing an imaginary line that is passing through the molecule about which, if you rotate the molecule by a certain angle, okay, then the structure is completely identical. The structure will be completely identical. Imagine this. Imagine this. I have this molecule. Let's say that I have this molecule. Yep. Alright guys, I have this molecule, hai na? Now this molecule, see, if I rotate it, I will be getting the same thing. Yes, axis of symmetry, rotated it, I got the same thing. Now if I rotate it again, I still got the same thing. I rotated it one more time, I still got the same thing. So do you see how many times I am getting the same thing? Exactly what it is denoted here as well. Here also it's denoted like this only. See, if you rotate it, you got the same thing. You rotated it, you got the same thing. You rotated it, you got the same thing. Alright. So that, my dear student, is called as your axis of symmetry. Clear hai? Is this clinical clear, guys? Is this clinical clear? Yes. Moving on. Center of symmetry. When we talk about center of symmetry, my dear student, everything else is simple, but the diagonal one is a little difficult. So I expect you all to just focus a little bit here so that you understand everything, okay? Now it is the center of the molecule such that when we draw a line from any terminal atom to the center, and if we extend it equidistant, same thing if you extend it, okay? Same thing if we equidistant, if we just, you know, extrapolate or increase it, so it meets the same atom on the diagonally opposite with respect to all the atoms. That's my center of symmetry. That's my center of symmetry. So this becomes center of symmetry. From here, see, this is equidistant to here equidistant. Yes, that's my center of symmetry. Okay. Now have a question for you. Let's see how many of you can do this, okay? My question is, does the following molecule have center of symmetry? Does the following molecule have center of symmetry? Check it out, guys. Tell me. Till then, I'm going to drink some water, but I need you all to answer. Chal. Yes, Meena, it should be enough, bacha. Huh. What's the answer? Yes, it is. How? How did we figure it out? See. Okay. H. So, opposite to it. This is where it is supposed to be, okay? If at all, मान लो, okay? Just imagine if the structure was a little bit like this. If the structure was like this, H, I, and if it was like this, H, I, then will you still consider it to be center of symmetry? Yes? Then will you still consider it to be center of symmetry? No, it will not be. But this, if this is the question asked, then yes, this is center of symmetry. Yes, this molecule has center of symmetry. Understood? Understood, everybody? Great. Okay. Moving on. Now let's talk about chiral. Chirality, I hope that everybody remembers it. Chirality, I hope that everyone knows it, isn't it? What happens? Mirror images, yes. Mirror images, they are non-superimposable, especially just like your hand. Every time we see our hands, we remember that this is a chiral thing, right? This is your chiral thing, isn't it? See, your left hand and your right hand, they are non-superimposable. You will not be able to superimpose them, okay? You will not be able to superimpose them. Is this clear? Is this clear, guys? Yes? Amazing. Alrighty. Now, moving on from here, let's understand calculation of number of optical isomer. How can we calculate the number of optical isomer? Let's do that. Case number 1. If the compound does not contain plane of symmetry, I'm going to ask you some questions from this, okay? There will be some questions from this. So, if the compound does not contain a plane of symmetry, let's just say that there is no plane of symmetry, yes? Then how will you calculate the number of optically active form? You will just keep it 2 to the power n, okay? And the number of mesoform will definitely be 0. Number of mesoform will be 0, but optically active form, this is your formula, 2 to the power n, okay? 2 to the power n. Alright, yes? Okay, Mridul Agarwal, bacha, please understand that do not try to do that. Do not try to do that. Please keep it kind. You have no idea what a teacher goes through. You have no idea what the other person is going through. Why would you do that? Would you like it if I start abusing you left and right now? And you know, when I came to this senior pod, I was really happy and I thought that, oh, students are so nice here. Yeah? Yes? So don't try to compare. I am not comparing you with some other student, no? Am I telling you that? Am I telling you that? No. Okay? Yes? And if you look at it, then both of us are doing as much hard work as we can to do the best for you. So please don't do that. This is your last warning. If I find another comment like this, I'll be blocking you from the channel itself, so that none of us get to see your comments like this. Okay? Yes, bacha? I hope you will agree to it. Yes. So you will not listen? You will not listen? It looks like that. You don't want to listen, no? You don't want to listen? Do you want me to block you? Anyway, okay. Now, case number 2. Okay, case number 2 is, everyone, let's just say that if the compound contains a plane of symmetry. See the first one, everybody, the first one is no plane of symmetry. No plane of symmetry at all. But in the second case, we are saying that there is a plane of symmetry. There is a plane of symmetry and it contains even number of chiral centers. It contains even number of chiral centers. If it is even number of chiral centers, my dear student, then the number of optically active form will be 2 to the power n minus 1. Please remember this formulas. Please remember these formulas because questions might come, okay? Questions might come, okay? Now, the number of mesoform is 2 to the power n divided by 2 minus 1. That's our mesoform formula, okay? All right? Yes, mesoform formula, all right? Apart from that, the total isomers here are 2 to the power n minus 1 plus 2 to the power n by 2 minus 1. What is n? N is our chiral center, okay? N is our chiral, number of chiral, okay? All right, everybody, do we understand this, guys? Do we understand this? Yes? All right, chalo. Moving on from here, let's talk about case number 3. If compound contains plane of symmetry and it contains odd number of chiral centers. See, we just spoke about even number of chiral center. Now we're going to talk about odd number of chiral center. Okay? So if there is if it contains odd number of chiral center, then what will happen? The number of optically active form will be 2 to the power n minus 1 minus 2 to the power n minus 1 by 2 it will be, okay? Because of, again, you know that, no? This thing, yes? What do we call it? What do you call it? Google slides to PPT. This always does happen, yeah. Google slide to PPT. This always does happen, okay? All right. Let me just correct it, everybody. 1 second. Let me just correct it. Where did it go? Always it happens. Don't know why. N minus 1 divided by 2. This is the formula, okay? This is the formula. Yes. Meena Ram, no. This is what it is. This is what it is, okay? Yes. 2 to the power n minus 1 minus 2 to the power n minus 1 by 2, okay? Now, number of mesoform is 2 to the power n minus 1 divided by 2, okay? This is our formula, right? This is our formula. You know what? Your chats are just a little too much. I'm hiding it so that I don't get to see it. I need to teach you satisfactorily, not watch your chat. Okay. And the total number of isomers will be, see, basically for total number of isomers, what you have to do is just from these two, you can find total number of isomers, which is equal to 2 to the power n minus 1. Yes. All right, everybody. This is clear. Do we understand this? Great. Now, I have a question for you. So, tell me, total number of geometrical isomers for the following unsymmetrical molecule. We know this. We know the formula, right? We know the formula. What will it be the answer? Unsymmetrical formula we know. Chalo. What is the answer? What is the answer, guys? CH3, CH, double bond, CH, CH, double bond, CH, Br. Tell me. What is the answer? Here we can figure out that n is equal to 2. N is equal to 2. That means that 2 to the power n, which is equal to 2 to the power 2, which is equal to 4. Is that right? Yes. So total number of geometrical isomer is equal to 2 to the power n, that is 4, right? It will be 4. Moving on from here. Now we come to the reaction. Acha, whenever we take a look at a reaction, what is it that we see in a reaction? In a reaction, we always see that on the right hand side, or on the left hand side, you have reactants, and on the right hand side, you have products, right? Normally, that's what we see, isn't it? Normally, whenever we write a reaction, how do we write it? We write it as A plus B gives you C plus D, isn't it? Yes. These are our reactants and these are our products. Am I right? Yes. Now, in a reaction, ideally or any day, what exactly happens in a reaction? In a reaction, actually what happens is, my dear student, there are bonds that are breaking in the reactant side and bonds that are forming in the product side. Yes. Once again, everybody, what is happening here? Bonds that are breaking and the bonds that are forming here in the product side. Yes, that's exactly what is happening. Am I right, everybody? Yes. So the reaction is basically, once again, what is written here is breaking of old bonds and formation of new bonds. Yes, formation of new bonds is happening in the product side. And how does breaking happen? Breaking can be a bond fission. It can be rupture of the bond. It can be cleavage, or it can be lysis. Lysis means disintegration of the bond. Yes, disintegration of the bond, that is also possible, right? Yes. Now, the breaking of bond can happen in two ways. It can be homolytic fission and it can be heterolytic fission. Okay. Now, we will talk about homolytic fission and heterolytic fission in some time. But is this much clear, guys? Is this much clear to you? Yeah? This is clear? Amazing. Very nice. Very nice. This much is clear to you. All right. ठीक है. Absolutely right. Yes. Okay. Homolytic and heterolytic fission. Now, what happens is, see, when we talk about reactant, do you think that reactants, that's it, that's all, suffices everything? No. In case of reactants, there is what? There is a substrate and there is reagent. There is a substrate and there is a reagent. Now, if you imagine that this is a country A, okay, this is country A. Let's say that this is country A and let's say that this is country B. Okay. Now, this country A is always very calm. Okay. This country is always very calm. But this country likes to attack. This country likes to attack. Okay. So, country A, let's call country A to be substrate because country A is providing a place where country B can come and attack. Yeah. Where country B can come and attack. So, we call this to be what? Yes. We call this to be what? This to be substrate. Alright. This to be substrate. And we call this to be reagent, isn't it? We call this to be a reagent. Yes? Everybody, are we clear on this? Are we clear on this? Just a second, guys. Let me block this. This is getting too much out of hand. Yes. Okay, so is this much clear, everybody? Do we understand this? Homolytic, we have understood this, right? Yes, I have. I have reported him for unwanted and hate speech. It was just too much. Is he still not gone? He's still not gone, huh? Hate him forever. Yes. Oops. Sorry. Sorry. Aditya bacha, wait up for some time. Wait up for some time. I'll tell you about that also, yeah? Don't worry. I'll tell you about that also. Okay. So this much is understood, everyone, isn't it? Yes, substrate. We have understood that what are reactants, what are products. We have also understood that there are homolytic fission and heterolytic fission. Now moving on from here, everyone, okay, let's understand the fundamental concept in an organic reaction. So the organic molecule also referred as a substrate. What does it do? It reacts with an appropriate attacking reagent. Remember, what did I tell you? Imagine if there is a country A, there is a country B. Country A is very calm, doesn't do anything. But country B, my dear student, always make sure that it is always attacking on country A. So country A becomes your substrate where the country B will come and attack, and country B becomes your reagent, okay, reagent. So the organic molecule, also referred as a substrate, it reacts with an appropriate attacking reagent and it leads to the formation of one or more intermediate. Yes, you will get intermediate, there will be an intermediate product, and then you get the final product where there is with the product sometimes byproduct as well. Okay, sometimes there are byproducts as well. Alright, so an organic molecule substrate, there will be an attacking reagent, then there will be an intermediate that is formed, and then finally you will have a product and a byproduct. Is this clear? Is this clear, everybody? Yes, we have understood this. Now from here we will also try to understand what else about it. Okay, let's try to understand this. Guys, let me just drink some water, huh? Have been talking a little too much. Got a little tired. Before talking about free radical and all, the reagent, 2 minutes break. After this, okay? After this, I'll give you 2 minutes break. Now, this attacking reagent can be of two types. Yes, this attacking reagent can be of two types. How? It can be an electrophile. Right? And it is also possible that it is a nucleophile. Electrophile, that means it loves electrons. Electro is basically your electron. Yes, this is your electron, and phile means that it loves electrons. Electron lover. What is it? Electron lover. And nucleophile, okay, nucleophile, does it love electron? No, it gives electron. It gives away electron, okay. So I can write gives away electrons, alright, gives away electrons, am I right? So basically this guy is rich like Ambani, and electrophile, these are like us. Am I like Ambani? No. Do I want money? Yes, I want money. Yes, I want money. Yes, I want money. So what will I do? I will have to work for someone, no? Maybe, who knows, that I might have to take a job with Reliance Jio or some place, isn't it? To get some money from Ambani. Ambani has a lot of it. So he is a nucleophile, he's rich. But I am an electrophile, yeah. I'm an electrophile. And so are most of us, right? Majority of our country, all of us are electrophiles. We need the money. We are not as rich as Ambani, right? Do we understand this, guys? Okay. Now when we move on from here, now let's understand that what happens here is there is a possibility of free radicals, okay? There is a possibility of free radicals when homolytic fission. When homolytic fission happens, yes, free radicals form, right? In case of homolytic fission, free radicals do form, alright? Free radicals do form. Actually, by the way, what is homolytic fission? What is homolytic fission? Homolytic fission is basically, let's try to understand this, my dear student. Yes? Okay. Let's say that I have a pizza. If I divide it equally, then this becomes a homolytic fission. Okay? Then it becomes a homolytic fission. Alright? Otherwise, it will be an heterolytic fission. Mridul, dude, what is wrong with you, yeah? What is wrong with you? Why are you doing this? Let me teach, no? You don't like it, leave the class. Why are you bothering so much? Huh? What happened? What happened to you? You don't like it, just leave. I tried blocking you, but you're coming back again. See, it doesn't matter to me because the point is that you are watching the session, you are commenting. It's just that your comments are not kind. You are still increasing my views by 1. Okay? The fact that you are sitting here and you are commenting like a jobless person, you are increasing my views. So thank you so much for that. But please keep your comments kind, or just don't comment at all. Leave the class. Please. Thank you for the views, but please leave the class. Because you're disturbing me right now. Let me teach. You don't like it? Amazing. No one is, holding on to your collar and asking you to sit here and watch my session. No. Okay. Leave the class. Go. There are students who are studying. Let them study. Okay? And I've seen you that you do this, okay? I've very well I've seen you. I've seen you in the previous class also that you were doing this with other students. I won't tolerate this, bacha. Okay? You do this with my student, then it's really not, you are not spreading awareness. Please understand this, you are not. Okay? Just come in the morning and watch other teachers' session, how many students they are getting, okay? Don't try to do that. And do you know what is my qualification? Do you think you will get there? The fact that you have written IIT B and you're behaving like this shows you where you are from. Shows where you are from. You think you will get there? Do you know my qualification? What gives you the right to judge me? Huh? What do you know about me? Exactly. You're not abusing, but you are. You are. With the right words, with good words, you are. You are disrespecting me. So don't. You are disrespecting me. Okay? Don't do that. Acha, anyway. Okay. Alright. So homolytic cleavage, do we understand? Alright, get back guys, get back. Enough of the disturbances by other people. Rakshan, thank you, yeah. Thank you, Rakshan. I think Alright. So representation. Yes, if we have a free radical that is forming, how do we usually show it? We usually show it with a fish hooked arrow or a half-headed, not full guys, not full. Basically what we do is we write it like this. See, what we do is we do it like this and we give a half-headed arrow, okay? Half-headed arrow, not full, all right? Half-headed arrow, not full, all right? Yes, got it? It's not a compliment, bro. Just shut up and go, yeah. So much your disturbance. This is just a mere act of getting attention from the teacher, so please stop it. Yeah, thank you so much for the views. Thank you so much. Now either leave or shh, let other teachers study, okay? Let other students study. I have blocked you, why are you not going? What is this stubborn behavior? I have blocked you, now you have come from other account, huh? I don't even care about your views anymore. Let me block you again. What else? Huh. Okay. Now moving on to homolytic fission. Let's understand the when does it happen? When will homolytic fission happen? Here are the characteristic, guys, okay? Here are the, sorry. Not, let's understand the characteristic and then we will understand when does a homolytic fission happen. For that also, I have a mnemonic here which will help you to remember when does it happen. Anyway, so characteristics, symmetrical breaking of bond. I've just told you, I gave you the example of a pizza. If you have a pizza here, break it into equal halves, that's basically your homolytic fission, isn't it? That's basically your homolytic fission. Now, symmetrical breaking of bond, that's exactly what we told you, right? Results in the formation of free radicals, okay? What will happen here? What will happen here? Here, you will have results in the formation of free radicals. You will get free radicals, exactly what we saw here, see? Free radicals are forming here, isn't it? Free radicals are happening here. Now, usually what happens is it takes place between two atoms. They have no difference or very small difference in the electronegative value. The electronegative values are almost similar, okay? Electronegative values are almost similar. That's when we get to see this kind of fission, all right? And when is it favored? When does it happen? It happens when you have heat, it happens when you have electricity, it happens when you have light. Light bole to UV light. It happens when you have a peroxide and it happens when there is a radical. So basically it favored by the presence of helper, that is heat, electricity, light, peroxide and radical. This is clear? This is how we can remember this, guys. This is how we can remember it. Helper is heat, electricity, light, peroxide and radical, okay? UV light is what we have, okay? Oh, thank you Hari's ideas, thank you. You guys are so sweet, yeah. Achha, anyway, so symmetrical breaking of a covalent bond such that both participating atoms, okay, they retain one electron, each resulting in the formation of free radical. Yes, each resulting in the formation of free radical. That's our homolytic fission. Now, homolytic fission with love can also be called as symmetrical fission. What do we call it? Symmetrical fission. Understood? Understood, everybody? Yes? Okay, great. Amazing. Moving on from here, now let's understand heterolytic fission. What is heterolytic fission, Baba? What is heterolytic fission? Heterolytic fission will occur when one of them is more electronegative and they will pull the electron. When one of them is more electronegative and they will pull the electron towards them, that's when heterolytic fission happens, okay? Now, in case of heterolytic fission, do you think that just like homolytic fission, they will also have free radicals? No. So here what happens is an unsymmetrical breaking of covalent bond happens such that one of the two participating atom, they retain the bonding electron pair. They take the bonding electron pair and they keep it with themselves. They don't give it to the other one. The other one stays as it is. The other one just stays without getting anything. But the first one or whichever is the more electronegative one, they pull the electron towards them. Yes, they pull the electron towards them. Okay, do we understand this? Like in case of this, as you see this electron, it was taken by A. Why? Because A was more electronegative than B. In this case, what happened? B kept the electron. That means that B was more electronegative. Yes, B is more electronegative. Can I write that? Can I write that? Is this understood? Is this understood, everybody? Yes. So what is happening here? Here, either you will get a carb anion or you will get a carbocation. Positive charge cation, negative charge anion, right? This is what you will get. In case of heterolytic fission, what happens? You get a carbocation or you get a carboanion. Making sense? Is this easy peasy biryani tasty, everybody? Clear hai? Clear hai? Yes? Yes, everybody? This is clear, right? This is clear. Awesome. Now, once again, coming back to the attacking reagents, I just gave you a gist out of it that the attacking reagents, they can either be an electrophile or they can be a nucleophile. So, who are electrophiles? The electrophiles, like I told you, they are electron loving or they are electron attacking. What do? They are electron loving. They love the electron. They take away the electron. They will take the electron from someone else. Yes, yes, they will take the electron from someone else. Whereas the nucleus, nucleophile, they love the nucleus. They have a nucleus attracting nature. They attract the nucleus, okay? Alright, they attract the nuclear. And who will they attack on? They will attack on electron deficient center, okay? Wherever they see that, this fellow does not have an electron. See what Ambani does, yeah? What does Ambani do? Ambani has a lot of money, right? So what does he do? Every year he goes to different colleges. He goes to IITs, he goes to IISCs, he goes to NITs, and he has a campus placement. Remember? Campus placement. Everywhere there is campus placement, and then you see, right, how much, what is the package that they get? They get like 1 crore package, 2 crore package, 5 to 6 lakh package, and all of this happens, right? He provides job. Why? Basically, he's trying to attack those people who do not have money. Like, we do not have money. We do not have money. So what does he do? He comes, he provides us with jobs so that we get some money. Same thing is what this nucleophile also does, okay? This nucleophile also, what does it do? It is a nucleus loving, okay? It's a nucleus loving. So it attacks on those who has electron deficient. That means those who have less electrons, okay? Is this clear, guys? Okay? We understood this concept. Now, let's read a little bit more about the electrophiles. Okay? A reagent that takes away an electron pair. That takes away an electron pair is called electrophile. Yeah. Electron pair. It takes away an electron pair. Obviously, electrophile. Electron file loves the electron. So, will take away the electron pair. Yes? There are positively charged or neutral species which are deficient of electrons, and they can also accept a pair of electrons. So it's not always the case. It's not always the case that they will have to have, they will have to have what? They will have to have some charge like this. They can be a positively charged or a neutral species also. They can be a neutral species who is deficient of electrons. Who is deficient of electrons? And they can accept a pair of electron. Are you understanding? Are you understanding, everybody? Is this clear, guys? Is this clear? Yes or no? Yes or no? Yes or no? Can I see some chats? Acha, electrophiles, they are electron deficient. Yes, they are electron deficient. They are love electron, negative charge lover. You can call all of them. Okay? You can call all of them. Now, these electrophiles, they are electron deficient species which has a tendency to attack electron rich. Okay? Electron rich center. If they see that somebody else has electron rich center, somebody else has more electrons, they will go and attack. They will go and attack. Like, do you remember there was this country which did not have oil, so it tried to attack all the other countries where there was oil. Do you remember? I'm not going to name the country, but do you remember? There was this country which does not have much oil, so wherever they saw that, this fellow has more oil, so they were trying to attack everyone. Hi Tarun sir. Guys, how many of you know Tarun sir? Tarun Sharma sir, do you know? He is also from Vedantu. He takes care of hybrid session. He is here in my session. He just joined. Thank you, Tarun Sharma sir, for the support. Thank you. No, bacha, hydrocarbon I haven't started yet. Looks like we will not be able to complete hydrocarbon because we still have a lot of GOC part that is left. Yes, okay. Acha, moving on. There are different types of, did I say two? No, there are different types of electrophiles, okay. Which are these different types of electrophiles? Let's understand them with some examples, okay. Positively charged electrophile. There are positively charged electrophiles also, okay. Now, who are the positively charged electrophiles? NO2, see, plus sign is here. CH3 plus sign is here, Br plus sign is here, Cl plus sign is here. So, these are positively charged electrophiles, okay. These are your positively charged electrophiles. Neutral electrophiles, AlCl3, SO3, PCl3, these are your neutral electrophiles, okay. These are your neutral electrophiles. Got it? Moving on from here, now let's understand nucleophiles, okay. There are lot of examples actually, guys, lot of examples. So if you have a little bit of time, just check it out, okay, just check it out. Or what I will do is, I'll send you a little bit of my handwritten notes also, okay. I'll send you a little bit of my handwritten notes that I have with me. From there you can read some more examples, okay. From there you can read some more examples. Where will I provide the handwritten notes? In the Telegram channel. So don't forget to join the Telegram channel. Acha. Now let's talk about the nucleophile, okay. Nucleophile is basically a reagent which brings an electron pair. It brings an electron pair. Like, for example, I have a little bit more qualification. So what am I doing? I'm bringing you the knowledge of chemistry that I know. Whatever I know, I am bringing it to you, right? I am bringing it to you, isn't it? So a reagent that brings an electron pair towards somebody else, that's called as a nucleophile. So nucleophile is basically electron rich and it seeks electron deficient size. Remember the Ambani example? Yes, Ambani has so much money that fellow, he has to do some charity. He has to give other people job, right? That's why every single year he goes to different colleges. Not him, I mean he has a team who does that, right? He goes to different colleges and those who need a job, those who need some money, he will go give them a job and he will make them work and he will pay them, isn't it? Same way, a nucleophile also, see, it's an electron rich and it seeks electron deficient sites, okay? Alright, basically it's a nucleus loving or nucleus seeking, okay? Nucleus loving or nucleus seeking. Now there are also different types of nucleophile. What are these different types of nucleophile? There are anionic nucleophile, OH minus Cl minus CH3, yes, CH3O minus NH2O minus NH2 minus. These are your anionic nucleophile, yes. You also have neutral nucleophile, H2O. How can we stay away? When we talk about neutral nucleophile, H2O definitely comes up. ROH, RSH, ROR, etc. These are your neutral nucleophile. Then comes your pi bonded nucleophile. Yes, pi bonded nucleophile. This is an example. This is an example. This is an example. These are your pi bonded nucleophile. Apart from that, you also have an ambidentate nucleophile like this, etc. Okay, which we just spoke about. Sometime back only we spoke about it, isn't it? Yes, sometime back only we have spoken about it. Will there be short note in the session PDF? I will provide it, bacha. I will provide the short notes. I'll provide this PDF and I will provide you a little bit of my handwritten notes as well so that you can study from it, okay? Moving on. Now comes something called as electron displacement effect. Now, electron displacement effect can be divided into two categories. There are permanent effect and there are temporary effect. Permanent effect is, my dear student, inductive effect, mesomeric effect or resonance effect that you can say, and there is hyperconjugation effect, okay? And we will talk about hyperconjugation effect. Then there comes temporary effect where there is electromeric effect and inductomeric effect. So first let's do the permanent effect, right? Permanent effect is from where most of the questions in the exams you will see, okay? All right, everybody, let's start. So there are these three are your permanent effect, my dear student. Inductive effect, mesomeric effect. Actually, mesomeric effect and resonance effect has a very little difference. However, in NCERT, they have considered that mesomeric and resonance effect are the same. But there is a very thin line, very blur line between these two. Okay. So, but anyway, we will learn both of them. But still, you can consider that mesomeric effect and resonance effect are the same. Okay. And then hyperconjugation effect is also there. Temporary effect may you have electromeric effect and you have inductomeric effect. Is this clear? Is this clear, guys? Yes, it is. Yes, it is. I hope that everybody understood. Now, when we talk about inductive effect, okay, when we talk about inductive effects, okay, so what is inductive effect? And also we just spoke about that the inductive effect is it's a type of electron displacement effect. That means there is a shift in the position of the electron, isn't it? Electron deficient effect, the electron displacement effect. That means there is a shift in the position of the electron, which means, as you see, the displacement, that is shifting of an electron, okay, shared pair or along the carbon chain, yes, shared pair along the carbon chain due to the difference in electronegativity of the groups present along with carbon chain, that's called as inductive effect, okay, that's called as inductive effect. Are we understanding, everyone? Are we understanding? Yes, guys. We can also say that shifting of sigma electron. What can we say? Shifting of sigma electron towards more electronegative. Let's write that down. Okay, let's write that down here so that we don't get confused. Shifting of sigma electron towards more electronegative. Okay, towards more electronegative atom. That's your inductive effect. Yes, is this understood? Due to yes, very good, Mahalakshmi, very good. Acha, now now see, this is a carbon, and this is G. G means functional group. G means functional group. Okay, G means functional group. Now what is happening here? Tell me. What is happening here? Tell me. What is it doing? What is it doing? Yes. What is it doing, everybody? What's going on here? Let's just say that imagine this is more electronegative here. Okay? Yes? Let's just imagine that this is more electronegative. So because this was electronegative, there is a delta minus sign here. So what did it do? It pulled the electron towards it. It pulled the electron towards it. This is more electronegative. So it pulled the electron towards it. When it pulled the electron towards it, then what happened? Here a delta positive charge came. Now this also has become a little more electronegative than this. So what will this do? This will again pull it towards this side. This will again pull the electron from this side. So here you will get a delta plus. Yes? Yes, just because this functional group was more electronegative, it pulled the electron towards this side. Yes, the sigma was pulled here. When this happened here, then what happened? Then again, this one became a little more electronegative. So from here also it was pulled. From here also it was pulled. Right? Now opposite of it. See, now this time this carbon was more electronegative, not the functional group. Not the functional group. This carbon was more electronegative. Now because this carbon was more electronegative, yes, partial charge, bacha. Yes, partial charge, yes. Because this carbon was more electronegative, what happened? So from the functional group it was pulled. From the functional group it was pulled. Now when this happened, here what happened? Again from here also this was pulled. Right? From here also this was pulled. So you see that delta negative happened here. Yes? Now, do you notice that I'm only writing it for 3 here? Only for the 3 till here. 1, 2, 3. 1, 2, 3. Only for 3 I have showed it. Why? Because inductive effect depends on distance. Because inductive effect depends on distance. Yes? Absolutely, guys. Absolutely. Make sense? Nonsense, everyone. Does this make sense? Does this make sense, everybody? Yes or no? Yes or no? We understand this. Awesome. Now, what are the characteristics of inductive effect? Inductive effect also has some properties that we will have to read about, right? Everywhere we have to read about properties. So, we already know that it is a permanent effect, that I have told you, right? We already know that it is a permanent effect. It takes place between the atoms that are bonded by a covalent bond. Yes, there has to be a covalent bond, then only it takes place. What is it? It is just the shifting of a sigma electron pair and not complete transfer. Complete transfer is not happening. Just the shifting of the sigma electron pair is happening, okay? Just a shifting of sigma electron pair. It is observed. Why is it observed? Because of electronegative values, because of the difference in the electronegative values of the bonded atoms. That's why we see this, okay? That's why we see this. Yes, bacha, being a NEET aspirant also, you can watch this. Yes, because the chemistry is almost similar. Hai na? We understood. Acha, now inductive effect can be of 2 types. Inductive effect can be of 2 types. It can be plus I effect, or it can be minus I effect. So let's read about plus I effect, everybody. What is a plus I effect? Plus I effect is when an atom or a group of atom, it donates electrons to other atom via a sigma bond, okay, are called as electron donating group, EDG. What can we write? EDG. Once again, everybody, do we understand this? An atom or a group of atom donates electrons to other atom via sigma bond, okay? Via sigma bond are called as electron donating groups. And an effect of donation of electrons to other atom is called as plus I effect. That means it is donating. It is donating. When it is donating, it is a plus I effect. Huh? Yes, when it is donating, it's a plus I effect. So, some of the examples of these electron donating groups in the decreasing order of donation ability are, let's write this, okay? Let's write this here. CH2 greater than NH greater than O greater than Q. Tertiary alkyl, secondary alkyl, primary alkyl, CH3 and H. Okay. I said Q, but you understand that it's COO minus. Okay. COO minus. Do we understand this? Do we understand this? Yes. This is the decreasing order of donation ability. Decreasing order of donation ability. Yes, guys. Making sense? Clear? Easy peasy biryani is tasty. Till now is everything clear? Till now is everything clear, guys? Okay. Yes? Yes, everyone. Acha, plus I effect, when does it happen? When does it happen? Let's just say that there is C. Yes? And let's say that there is not X. Let's call it Z. Let's call it Z. So, electronegativity of C and electronegativity of Z. What will be the difference here? Which one will be more? Which one will be more? Tell me. Which one will be more, guys? Only 2 hours done. This will last another 1 hour, yeah? We have a lot of questions also. We haven't even practiced yet. There are a lot of questions coming up. Anyway, tell me. When plus I effect is happening, what will happen? अरे यार ये लड़का फिर आ गया. बताओ कैसा चेप है. एक तो इसको मेरी क्लास नहीं पसंद आ रही. A, this fellow is not liking my class. B, he's telling me I don't teach him properly. And third, he's just not letting me. What a leech, yeah. I think that's a compliment. That's a compliment. So whatever, I'm not considering your words anymore. So what did I say, guys? What did I say? I said that an atom or a group of atom donates electrons to other atom. Yes, donate electrons to other atom. You tell me, guys, what's the difference? What's the difference? What's the difference here? Can we say that it will be like this? It will be like this. Yes. So electronegativity of C will be more than electronegativity of Z. Okay. Yes. All right. Moving on to minus I effect. Let's understand minus I effect. Okay. Now minus I effect. So obviously the opposite. No. We have just learnt about plus I effect. Plus I effect, we saw that electron donating group. So here can we say EWG, that is electron withdrawing group. Yes, electron withdrawing group. Yes. So an atom or a group of atom which withdraw electron from other atom through sigma bond, they are called as electron withdrawing groups. An effect of withdrawal of electron is called as minus I effect. Okay, an effect of withdrawal of electron. When you withdraw electron, that's your minus I effect. Okay. Now some of the examples of this EWG in decreasing order is you have NF3, NH3, NO2, SO3H, CN, CHO, CRO, COOH, COOR. I'm not very sure how to remember this, but I guess not F, not H, just no 2. So how do we say it? Not F, not H, just no 2. So CN, Ko, Kro, Kukur. Kukur in Bengali is a dog. So somehow I think I remembered like this. Yeah. So I think you can try. CONH, then comes all the halogen here. These are all the halogens. Then it is O, or C double bond CH, then C6H5, then it is CH double bond CH2, and then finally it is hydrogen. You can try. Not F, not H, just no 2. So CN, Ko, Kro, Ku, Kur. Okay. Then CONH, then all the halogens, then OH, OR, CCH, C6H5, CH2, and hydrogen. This part I have, like, from here I have no mnemonic how to remember, but this much I think you can remember, as I told you. Yes, this can be a trick if you want to remember it. Yeah, you can be, because I'm a Bengali, so you know, ku and kur, it made me kuku, it made it kukur. Kukur means dog, so I could remember it. But if you have anything else in your own language, in your vernacular language, maybe you can try it out. Chalo, theek hai. Moving on from here, I have a question. Now I have a question. Tell me, guys, which of the following belongs to plus I group? Plus I group. Tell me. Plus I group. Which one of the following belongs to plus I group? Very easy, very simple, very easy, and it's a pretty obvious question. So tell me, guys. Very good, Beyblade Bus song. Well done. Clap for yourself, everybody. It is the C. C is a plus I group. Okay, C is a plus I group. Well done. Now, the inductive effects of the group, tell me. You have NH3, you have deuterium, you have CO2, and you have COOH. We have just learnt, no? We have just learnt, isn't it? This is -1. NH3 is minus I effect, isn't it? Deuterium will have what? Plus I effect, isn't it? CO2, we just did, no, some time back. Yes, this will be again plus I effect. Yes, and then COOH, Kur, remember? So that will be again minus I effect. So that means it is option A. That means it is option A. Got it? Yes? Yes. Alright, bacha. Now let's talk about the resonance effect. Okay. Now let's talk about the resonance effect. Shall we? Are we ready? Okay. Now, delocalization of pi electron. See, in the inductive effect, we spoke about the sigma electron. Remember, in the inductive effect, we spoke about the sigma electron. Now, we talk about pi electron, okay? So, delocalization of pi electron in conjugation is known as resonance. What do we call it? We call it as resonance, all right? So, basically, if you see in resonance, what is happening? See, these are your resonating structures, okay? These are your resonating structure. See how it moves. See how it moves. See, here you have more electrons. So, this moved from here, okay? It moved here. This moved to here, okay? That means that you will get, see how this electron moved here. So, here you have a double bond now. Here you have a double bond now. Yes, here you have a double bond now. Now that you have a double bond here and you just saw that this one moved here, this one moved here. So see how you have the electron pair here. You have the electron pair. Now the moment you saw that the electron pair is here, what will happen? What will happen? Once again it will come back here. Once again it will come back here. Acha, remember sometime back only I told you that money flows from Ambani to us. Because why? Ambani is rich. Whoever has it more will give it to us. Right? Whoever has it more will give it to us. Exactly the same way, wherever you see that there is more electrons, that will flow. That will flow, okay? That will flow. Are you understanding? Just check it out. Here, see? From here, it moved here. From here, again, see, now that you see a double bond here, from here it tried to move again here. Are you understanding? Do you see it? Do you see it, guys? From here, it moved to here. Yes? And once again, when you saw that there was an electron here, it again tried to move back. It again tried to move back. So that means that I can just write a dotted line here and I can tell that the electrons had come. The electrons at certain point were present here, right? I can write that. I can write that, isn't it? So this, my dear student, this becomes my resonance hybrid, okay? This becomes my resonance hybrid. One more thing that you have to understand is that the resonating structures, these are all absolutely imaginary. The resonating structures, these are all absolutely imaginary. This thing is real, okay? This thing is real, okay? This thing is real. Understanding, everybody? Getting it? Is this all clear? Yes? Amazing. Now, let's talk about the conditions for resonance, okay? What are the conditions for resonance? Pi alternate pi bond. When you have a pi alternate pi bond, as you can see, here is a pi bond, here is a pi bond, here is a pi bond. When this happens, see, from this, it will try to move. From this, it will try to move. When it moves here, see, the electron is here. The electron is here. The moment the electron comes here, it will try to move again. And from this, the pi bond will again try to move here. Yes? Do you see it? Do you see it? Do you see it? Yes? Now from here, once again you will see that this pi bond will try to move here. The moment it tries to move, here you get the electron. Here you get the electron. Yes? Do you notice, everybody? So basically this becomes my hybrid, or I can just write it like this, okay? I can write a dotted circle inside, and that will rest my case. Yes, that will rest my case. Got it? Moving on from here, you have pi bond alternate negative charge. If you have a pi bond and if there is a negative charge, if you have a pi bond and if there is a negative charge, then what will happen? Then what will happen? See what is happening. Allyl carbon ion I have taken. This, what did I say right now? What did I say? Just like how from Ambani the money moves to us, right? Whoever has it more, from there it will move to us. Very similarly, here you see that there is a double bond, so the double bond will try to move here. Yes, and here you see that there are electrons here. This will try to move here. That means I will get to see a double bond here, and I will get to see that the electron has moved here. Yes, I will get to see that the electrons are here. Yes, are you getting it? Are you getting it? Yes, everybody? Amazing, amazing. Yes. Now, if I have a pi bond alternate positive charge, if I have a pi bond alternate positive charge, then what will happen? Same thing, yeah. Same thing. Yes, same thing. Basically what will happen, from the double bond it will try to flow here. Yes, it will try to flow here. Yes, and see what is happening. See what is happening. The double bond has moved, the positive charge has moved here. That's it. That's it. That's all. This is your allyl carbocation. This is for your allyl carbanion. Yes, understanding guys? Amazing. Now, if we have a pi bond alternate odd electron, pi bond alternate odd electron, then what will happen? Then what will happen? For example, allyl free radical. If we take allyl free radical, then what will happen? See, check it out. Check it out. See, the double bond is going this side. Yes, the double bond is going this side. It can also come this side, right? So basically what we are doing is, my dear student, yes, the double bond we have shifted it here, and the free radical that was here, we have shifted that to the position 1. We have shifted that to the position 1. The double bond moved to this, and the radical here, that we have shifted to position 1. That's it. That's it we have done. Does it make sense? Does it make sense? Do you see what is the difference in the two structures? Yes? Do you see the difference in two structures? Yes? Absolutely, my dear student. Absolutely. Now, lone pair alternate positive charge. Lone pair, and you have alternate positive charge. Okay? Alright. So, here also, see, here also what we are doing. See, here also what we are doing. Almost the same thing that we are doing. Yes? Almost the same thing. So, this lone pair, it moved here. So, we get a double bond here. We get a double bond here. Yes? And a positive charge here. Right? And we get a positive charge here. Isn't it? Isn't it? That's all that we did. That's all that we did. Yes? Got it? Clear hai? Is this all clear, guys? Is this all clear? Amazing. Amazing. Okay. Now let's understand stability of resonance. Okay. Now let's understand stability of resonance. See, among various resonating structures, okay, non-polar resonating structure is more stable than polar resonating structure. What will happen? The non-polar resonating structure will be more stable than polar resonating structure. Yes, more number of covalent bond is considered to be more contributing than others. Do we understand this? So if we have a non-polar resonating structure and we have a polar resonating structure, which one will be more? Which one will be more stable? Obviously, the non-polar resonating structure will be more stable. Okay, the non-polar resonating structure will be more stable. Got it, guys? Is this clear? Yes, is this clear, everybody? Got it? Got it? Amazing. Next, if two resonance structures have same number of bonds, then that structure in which octet of every atom is completed. Octet of every atom is complete. That will be more contributing than the structure having incomplete octet. So basically, what have we understood? We have understood non-polar will be more this thing, right? So that means NPO we have understood. NPO, non-polar will be more stable. Octet will be more stable. Yes. Coming to the third point, if the resonating structures have number of bonds, then the neutral structure will be more stable than the charged structure, and if both are charged, then resonating structure of that which is a less charged resonating structure is more stable. Okay, either it will be neutral that will be more stable, or the less charged one will be more stable. Okay, that means that we can write that N neutral will be more stable, or less charge will be more stable. Yes, so NPONLC, do we understand this? Moving on from here, in case of a charged, okay, in case of charged resonating structure, the most stable one is that in which the positive and negative charge reside on the most electropositive and most electronegative of the structure respectively. Yes, so here see, you have a charge here, you have a charge here. Which one will be more stable? the B1. This will be more stable, okay? This will be more stable. Is this clear, guys? Is this clear? Yes? Thank you. Awesome. Chalo. Moving on, everybody. Yes. Resonating structure in which unlike charges are closer is more contributing than that structure in which unlike charges are far away. If the unlike charges are far away, then that will not be stable. In which in this one where the unlike charges are closer to each other, that will be a better one, okay? That will be a better one, okay? So in here, if I see this example, which one do you think will be more stable? Which one do you think will be more stable? Obviously, this and this will be more stable. See, positive, negative, opposite charges are closer. Yes, opposite charges are closer to each other. Yes, that is why 2 and the 4th structure, they will be more contributing than the others. Is this also clear, guys? Is this also clear, everybody? Hannah? Clear hai, guys? Yes or no? Yes? Okay. Great. Moving on then, okay? Resonating structure in which like charges are further away. If the like charges are further away, is more contributing as compared to structure in which like charges are closer. Obviously, yeah, this is common sense, isn't it? This is super duper common sense, everybody. Like charges, the further it is, obviously it will be more stable. If they are closer, then there will be repulsion, isn't it? Then there will be repulsion. If it is further away, then it is better. Exactly, that is what they are speaking about. Now, let's do a question, everybody, okay? Let's do a question. So, determine the order of stability of the following resonating structure. Let's check out how many of you can answer this. Chalo. हाँ जी, the over smart बच्चा, बताइए जरा आंसर क्या है, देखे आपको आता है कि नहीं ये? हाँ? All of these time, the way you are disrespecting me, let's see if you can answer this. I doubt you will be answering. You are not in IIT. Had you been in IIT, you wouldn't have been having so much time to see this. I have been in one IIT. Life did not seem so chill. Anyway. Okay, Pranati, Prem, Kelvin, Guitar Guy, all of you are answering. Oh, mixed responses, huh? A, C, D, everything. Somebody say B also. All of the options will get covered then. Huh? What's the answer, guys? Option A is the correct answer. So many of you said that D it is. Huh? No, it is option A. Why is it option A? See, charge separation, it will reduce the... Yes, charge separation reduces the stability of resonating structure. We have just read, yes. And if charge separation exists, then what will happen? The structure with opposite charge closer is more stable. So 1, then 2, and then 3, isn't it? 1, 2, and then 3. 3 will have the least, yeah, see, the charges are so far away. The charges are so far away. Here it is closer, but look at this also. Look at this structure. So this will be more stable, isn't it? Yes? IIT Guwahati, check it out. You can find me. If you're still thinking that I have not been here, check out the pictures of IIT Guwahati Chemistry Department. You will see. Yeah? Now stop bothering me, yeah? Please. Please, I request you. Why are you such a stubborn leech? Anyway, taking into account of hybridization and resonance effect, rank the following bonds in order of decreasing bond length. Tell me. Haha, you are not. You are a liar. You think that behind the laptop, if you sit and if you comment, you have a lot of power, but you don't. You know, you're just a liar. You're just a liar. 'Cause 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 ' Thank you, Amal. You're so cute, yeah. Thank you so much. Batao, batao, look at this, come on. No, Pranati, a little bit more you think, just a little bit more if you think. Taking into account, I want him to answer one question. See, he won't be able to. He's saying no, he's from IIT Bombay. He won't be able to answer a single question because he's just wasting his time. Yes, Luxury Hitler. Very good. Very good. It is option D. Option D. Yes. See, all of them are equal. Taking into account of hybridization and resonance effect, if you rank it, then all of them are equal. Also, don't you know that the resonating structure, what will happen? It's in between it is in between the length. The length is in between, isn't it? The length is in between. So, yep, that's where you go. Option D is the correct answer, okay? If you consider resonance, all the bonds have partial double bond character. So, the bond length is in between the single bond and the double bond. All of them will be of the same length. All of them will be of the same length. Hi, Nishan. Thank you so much. Yes, you are a lot late, yeah. You're 2.5 hours late. What happened? Where were you? You forgot about the class, is it? You forgot about the class, is it? Anyway, moving on. Next question. The least stable. Why 2 incorrect, guitar guy? Why? Chalo, koi baat nahi, it's okay. Happens sometimes. The least stable canonical structure among these is. Tell me. The least stable, guys. Which one will be the least stable one? Think and answer. C. Really? It will be B, no? Hey, C will be stable. See, opposite charges are close to each other. Opposite charges are close to each other. In structure 2, more electronegative element carries the positive charge. Hence, this will be the least stable one. So, this will be the least stable one. Okay. Yes. Anyway, now we will go to mesomeric effect. Remember, I told you there is a very thin line between the mesomeric effect and the resonance effect. So anyway, now let's study about mesomeric effect. However, like I said that in NCERT they are considering mesomeric effect and this thing, what you call resonance effect. We consider them to be same in NCERT. However, there is a very blurred line. Let's just understand this, okay? So in mesomeric effect also we have a plus R or plus M effect, okay? We have a plus R or plus M effect. So an effect in which an atom or a group of atom donates electron pair to the conjugated system, okay? Conjugated system through resonance is termed as plus R or plus M effect. Understanding what am I saying? What did I say? I said that an effect in which an atom or a group of atom donates electron pair to the conjugated system, okay? It donates electron pair where? To the conjugated system through resonance. Through resonance, then we call it to be as plus R or plus M effect. Got it? Clear? Moving on, let's understand some more groups which shows plus R effect when attached to conjugated system are. These are your example. These I think you can learn it, okay? These I think you can learn it, okay? Alright, I will give you the PDF anyway in the Telegram channel, so you can just check it out, okay? Moving on. Plus M effect is also showed by these ones. Let's not read into this because like I said, I'll be providing you the PDF, okay? You can read it. Now let's talk about the minus R or minus M effect, okay? If we talk about the minus R or minus M effect, then what happens? An effect in which an atom or a group of atom attached to the conjugated system, okay, withdraws electron. Recently we have studied what it does. It donates, but here it withdraws electron pair through resonance is termed as minus R or minus M effect. Alright, yes, alright, got it, understood, understood everybody, awesome. Yes, again these are your examples, you can just read them, you can just go through them, you will be able to understand just the examples. If you have to remember, basically you have to memorize this, which I think you can do, okay. Now let me tell you about the application of mesomeric effect also, okay. What are the applications, where are they used? So, application, before application, let me also tell you the stability of carbocation, okay. More resonance in carbocation, more stability of carbocation, okay. If there is more resonance in carbocation, then more stability of carbocation you will see. Aromatic cations, they are more stable than the non-aromatic cations, okay. These are the two stability of carbocation. Stability order is also written here, okay. Stability order is also written here, that you can check it out, my dear student, okay. And here stability order of carbocation we are still continuing. So here if you see, the stability order is 2, 3, 1. Why? True. Here you see that there is an increase in positive charge by minus I effect. Okay. Alright. Then here you see that there is an increase in positive charge by minus I and minus R effect. So minus mesomeric effect and minus inductive effect. Alright. Both of them are happening here. Both of them are happening here. And here if you see increase in positive charge again by both the effects. Again by both the effects. So we will write it as 2, 3 and 1. Alright. Again because of the positions as you see. Because of the positions as you see. So 2, 3 and 1. Clear hai? Clear everybody? Is this clear? Yes. And very much like this, you have similar stability orders that are written here. Once again, since I will be giving you the PDF, you can just go through them, okay. More resonance in carbanion, more stability of carbanion, okay. Oof. Are you seriously going to do this? Why? Why would you do this, yeah? Why are you spoiling my class? From such a long time, you're just behind me. I mean, so disappointing, bro. Again and again, I have blocked this guy 3 times and he's just coming back again and again. More resonance in carbanion, more stability of carbanion will be there, okay. Alright everybody, moving on from here, stability order is again written here. Let's skip through this, okay. Let's skip through this because these all you can just read it once and you will understand. There is nothing much that I have to explain here. That I have already explained what are the rules and everything, okay. Chalo, moving on from here. Now, here are a lot of questions. Everybody ready to do all the questions? Let's do all the questions. Let's do all the questions. Chalo. Let's take a look at all the questions. But before that, I am going to drink some water and take a little rest while you read the question. Chalo, read the question and try answering. Chalo guys. You didn't. You didn't. You absolutely did not. You grow up, bacha. Seriously, grow up. If you think that I will entertain you judging me, no. Already done it. 30 frigging years old and I have reached here, okay? So you don't teach me what I do, what I know and what I don't know. No, you didn't. You didn't. You really didn't. You have no frigging idea what are my achievements. So don't. Don't even go there. You will actually sink if you come near me, and if I start having a conversation with you, you will sink. I can do that to you. The things that I know, you have no idea. I will not. Why will I let you judge me? Huh? That I have given a lot of exams to judge myself. I'm not gonna be judged by every stranger that I meet on the internet. So, excuse yourself, please. Thank you so much. When are we getting a break? No break, yeah. Let's complete it today. Okay? Let's complete it today. Chalo. Anyway, did we do this? The decreasing order of stability of following cation is, tell me, what is the answer? The answer is option D, guys, option D, okay? You have Q, P, R, S. Q will be most stable, then it will be P, then it will be R, and then it will be S, okay? All right, moving on. The decreasing order of stability of following cation is, everybody, bolo. What is the answer? What is the answer? Do we have the answer, guys? I get to see all mixed answers, huh? A, C, A, whatever, okay. What is the correct answer? The decreasing order of stability of the following cation is. Let's find the answer. Let's find the answer. What's the answer? The answer, my dear student, here it is P. Okay, here it is P. First P, this will be the one, this will be the one, then it will be R, okay, then it will be Q, and then finally it will be S. Okay, moving on from here. Now we have to talk about acidity. Actually acidity, no, you have already gotten the hint when we were doing all of that R effect minus I effect. You got the hint. But anyway, let me just tell you a little bit, okay? Let me just tell you a little bit. Thank you, Luxury Hitler. Thank you so much. Anyway, so for an acid, from the law of mass action, we will get this, okay? We will get this term. So what is our Ka? Ka is our acidity constant, okay? Ka is our acidity constant or the dissociation constant of acid, okay? Or the dissociation constant. You understand dissociation, right? When it breaks. Dissociation constant, right? Now, Ka, it will obviously explain the strength of the acid. It will obviously explain the strength of the acid. And as we already know, pKa is equal to minus log K. This we have understood in the different chapters, right? We have understood in different chapters, isn't it? So, Ka is directly proportional to the acid strength, which is directly proportional to 1 divided by pKa, okay? 1 divided by pKa. So, pH is equal to minus log H plus. Got it? Yes. So, pH is equal to minus log H plus. Amal, that's a nice one. That's a nice one. Absolutely. So, acidic strength is directly proportional to stability of conjugate base. Yes, stability of conjugate base, which is directly proportional to the minus M effect, which is directly proportional to 1 divided by plus M, which is directly proportional to minus 1, which is directly proportional to 1 divided by plus I effect. Okay? Alright? Yes? Yes, everybody. Now, some more questions coming up, Chalo, batao. The decreasing order of acidity of the given benzoic acid derivative is. What's the answer? What's the answer, guys? B. Are you sure? Are you sure that it's B? Shall I show you the answer? It is B, yeah. Very good. Very good. Samyukta, very good. Yes, it is B, okay. Moving on, the decreasing order acidity of the given benzoic acid derivative is, what is the answer? The decreasing order acidity of the given benzoic acid derivative is. Yes, Amal. Well done, bacha. Well done. Very good. Yes, the answer is D. The answer is option D. Okay. Now, the decreasing order acidity of the given benzoic acid derivative, mostly they are all benzoic acid, which is the kind of question that you will get to see in your JEE exam. Okay. This is the kind of question that you will get to see. So, chalo, tell me. The decreasing order acidity of the given benzoic acid derivative is what? No, it was C. Ananta, very good. It was C. It has to be C, okay? Yes. Moving on from here, the decreasing order acidity of the given benzoic acid derivative is once again the same kind of question, but I hope that you will be able to understand. This is easy. This is easy. It's just halogens, FClBrI. FClBrI, that's all that is there. No. Acidity is inversely proportional to plus I. No, it's correct only. It's correct. This is fine. Anyway, tell me this. The correct answer is option A. Yes, option A. F, Cl, then Br, and then I. So this is the correct answer, okay? Moving on. Once again, another benzoic acid derivative. Let's practice this, yeah. Let's practice this. Let's practice this. Quick. Okay, I see the answers. Very good. Option B. It is option B. Next, okay? Next. 3 options you have. Alright, I get to see a lot of answers. It is option C. Option C. Mindy, amazing, yeah? Just came and you answered, huh? Fatafat. Awesome. Okay, now we will learn about basicity. Basicity is basically the basic strength is directly proportional to plus M, which is directly proportional to 1 by minus M, obviously, which is directly proportional to plus I, and that is directly proportional to 1 by minus M, okay? 1 by minus M, alright? Which means if we try to solve some more questions now, we will be able to practice here also. So basicity of amines in aqueous phase, let's just try to understand this, okay? So to determine the basic strength of amines in aqueous phase, okay? If we want to determine the strength of amine in aqueous phase, liquid phase, right? What do we have to do? We have to consider inductive effect. We have to consider inductive effect. We have to consider solvation effect, and we have to consider steric hindrance. So basically we are considering 3 things. We are considering 3 things: inductive effect, solvation effect, and steric hindrance, okay? That means that the order of basic strength is therefore experimental in aqueous state, as we can't give priority to stability provided by any factor. Okay, so two results that are very important for aqueous is, see, RCH3, from here it will go to R2NH. This is greater than RNH2, this is greater than R3N, and this is greater than NH3. Here also what are you saying? If it is R2CH5, then here see, R2NH is greater, then R3N is greater, then it is RNH2 is greater than NH3. Basically just this and this here. That's all that happened, okay? That's all that happened. Moving on from here, guys, basicity of aromatic amines. Aromatic amines, what do we see? Aromatic amines, we see that the nitrogen containing groups, they are nitrogen containing compounds. Nitrogen containing compounds are directly proportional to electron density on nitrogen, okay? Electron density on nitrogen. So in aromatic amines, the lone pair of electrons that are present on nitrogen is delocalized, obviously, right? It's very simple, very easy. So there is a lone pair of electron that is present on the nitrogen which is delocalized. Yes, which is delocalized. If that is delocalized, the electron density, it decreases due to resonance. Okay, it decreases due to resonance. An example is, see, C6H5NH2 is less basic than CH3NH2. Okay, C6H5NH2 is less basic than CH3NH2. Okay. All right, once again, there are a lot of examples that you can check it out. Okay, there are a lot of examples. Here, let's go and let's do some more questions. Chalo. The decreasing order of basicity of the given aniline derivative is. Okay, tell me. Just, what did I say? What did I say? C6H5NH2 is less basic than CH3NH2. You tell me, bacha. You tell me. Anyway, the decreasing order of basicity of the given aniline derivative is, bolo. What's the answer? Do we have the answer? All right, let's check it out. Awesome. Option C is the correct answer. Okay, option C is the correct answer. Next, you know what? I'll skip this. You can do this as I will give you the PDF anyway. I'll give you the PDF anyway. You can do this. Let's solve some previous year questions. Okay, let's solve some previous year questions. Chalo. The IUPAC name for the following compound is, okay, well done, amazing. Tell me, what is the IUPAC name for the following compound? Check it out properly, guys. What is it going to be? This has come in 2019 mains, okay, 12th April. What is going to be the name? I'll give you the PDF, Masood, in Telegram channel. I'll show you where is the Telegram channel also, don't worry, okay? No, bacha, I don't think only Tattva if you do, I don't think it's enough. With Tattva, you will have to do a lot of previous year questions and sample papers also, okay? Just Tattva won't be enough. It won't be enough. Anyway, the option is D, guys, D. 3,5-dimethyl 4-propyl hept 1N 6YNE, okay? It will be 3,5-dimethyl 4-propyl hept 1N 6YNE, okay? Moving on. The total number of contributing structures showing hyperconjugation involving CH bonds for the following carbocation is. Go ahead, let me know. Oh, thank you, Amal. Thank you so much. Are we done? Okay, here what will happen is, let's see. There are 6 alpha hydrogen to sp2 carbon, and they all can participate in hyperconjugation. Okay, they all can participate in hyperconjugation. So basically we will have 3 structures and we will have 2 structures like this. Okay, which amongst the following is the strongest acid? 5, it will be 5, yes, it will be 5. Alright, let's check it out. Let's check out the answer. The answer is D. Answer is D, guys. CHCN3. Okay, that's the answer. CHCN3. Alright, moving on. For the given compound X, the total number of optically active stereoisomer is, oh wow, 2018 advanced, guys. 2018 advanced. E, we have the answer here. Acha, listen. Now we come to your daily practice, okay? Daily practice. So that means DPP. Your DPP is here, okay? From here, all the questions that are there in the slides, you are going to solve it on your own. I'll be providing you with the PDF in the Telegram channel. Let me show you where the Telegram channel is so that you can join and you can get it. Where is the PDF? Just a second. Wait, what just happened? Huh. Ready? Got stuck up. Just a minute, guys. Oh, it froze. Why did it freeze? It's not going. It's not going. What just happened? Just a second, guys. When will we cover hydrocarbon? Wait, I think for hydrocarbon, we will take... Just a second, guys. Just a second. Let me show this. Okay, for some odd reason, this is not working out. Anyway, I think it's not working out, but no, I don't see anything. I don't see anything. Alright, let's forget it, everybody. The Telegram channel is right in the description box. If you just, just below this video, if you check out the description box, the Telegram channel is there. Also, if you haven't started your preparation and you're still waiting to prepare because you need more guidance and everything, then what you can do is below this video in the description box, you will also get to see the crash course link. The coupon code is YT Enlight. If you apply the coupon code, you will get a discount. YT Enlight is the coupon code, and you can also check out the Vedantu JEE crash course, okay, which has been launched, and it is going to start from 20th March. For hydrocarbon, I will keep another session, okay, because 3 hours is a little too much. If I start hydrocarbon also, everything will go just bouncing off over your head. All right, so we will see when we can do hydrocarbon. You study the GOC, I will send you the DPP, and we'll see how we can go about it, okay. Also, I have a session at 7:30 in the evening where we will be completing hydrogen, we will be completing S block, and we will be completing environmental chemistry, because from those chapters we can solve short questions, okay. So please be there. I'll see you. Tada, bye bye. See ya, guys. Bye.